Learning AI has become mandatory if you want to become AI proof and want to secure your job, especially in the data domain. But what exactly I need to study? From where I need to start? What are the topics I need to study for the data domain? I know. All of these questions are coming in your mind right now. That is why I have created this 4 hours long beginner friendly generative AI full course for the data domain, which will literally hold your hand and will make you understand all of the concepts which are required for you, including artificial intelligence and language AI, natural language processing, how to convert text into vectors, bag of words, word to vec, attention mechanism, complete transformers architecture with encoder and decoder, contextual embeddings, GPT models versus BERT models, prompting techniques, React prompts, vector stores, retrieval augmented generation, and much more. By the way, who is this guy? Well, I am an AI data engineer, extensively working on the modern cloud and big data technologies and frameworks, and I have obtained so many certifications. And you know what? With all of your love, I have officially become Databricks MVP. And yes, you can just congratulate me in the comment section. But why should you watch this video? Well, there are three reasons. Reason number one, it is well customized and structured for the data domain because obviously AI is everywhere. So what exactly you need to know in the data domain, this is the video. Reason number two, it will just boost your profile and will make you stay ahead of the curve. Three, all the notes and the reference materials are available to you so that you do not need to worry about anything. So if you are someone who doesn't have any prior knowledge and you want to learn AI, you have that hunger to learn AI, this is the video for you. So I am really excited to kickstart this masterclass. Just before that, hit that subscribe button right now because I have literally put so much of efforts to create this video, and this will motivate me to create more and more videos in the future. So let's get started with this amazing masterclass.
What's up, my fam? What's up? First of all, happy Sunday. And I am so happy. Why? Because finally, on your special request, let me tell you, I got so many messages, so many comments, so many things. Ansh Lamba, we want to become AI proof. Ansh Lamba, we want to make our career AI proof. Ansh Lamba, we want to secure our job. Ansh Lamba. So Ansh Lamba is here with this amazing generative AI, the ultimate guide. And I will not waste your time. So let me just tell you who should just watch this video. If you are a data engineer and want to learn AI, if you are a data analyst and want to learn AI, if you are in the data domain, okay, and want to learn AI, or if you are, let's say, hungry and very dedicated towards learning AI, no matter like what's your background, this video is for you. You should watch this video and you should continue this video. Okay. Quickly, let me just tell about prerequisite. The great news is zero prerequisite. Earlier, I was thinking like, let's cover something from the middle. Let's cover from this topic. Then I thought, Ansh Lamba, you have to start it from scratch so that everyone can understand and master AI. Because see, we know that AI is actually a concerning topic, because if you just want to become AI proof, if you just want to make sure your career is AI proof, your job is AI proof, you need to learn AI, but from the right perspective. What do I mean by that? All my data domain, my data family member, okay, my lovely data fam, they are very hardworking. I know they are trying to learn AI, I'm so sure, but they are saying, bro, how we can just learn AI in like with respect to data engineering or data, basically with respect to data domain, because data scientists are saying something else, machine learning engineers are saying something else, AI engineers are saying something else, software engineers are saying something else. Bro, how we need to learn AI with respect to data domain? Where is the guide? Where is the video? And I can feel you. But the good thing is, now you have the video, now you have the guide, now you have the ultimate step-by-step formula ready. Step by step, yes. I will literally hold your hand, okay, and I will just make you understand all the things. And let me just show you. Let me just show you like what you're gonna master. So first of all, we gonna learn all of these things. Okay, and let me just tell you, we gonna master so much more than that, but yeah, there was like this much of space, so I just listed a few topics, but we're gonna learn much more than these topics. So let me just quickly give you a brief. First of all, we will be just talking about AI and language AI, which is the very fundamental thing. Then we'll be just talking about NLP, which is called natural language processing. Then we're gonna talk about embedding vectors. Then we're gonna talk about B or W, bag of words. Then we're gonna talk about word to vec. Then attention, basically it is attention mechanism, and this is the backbone of modern architectures. Then contextual vectors, then transformers. This is one of the like my favorite chapter for this particular video, because here you will understand how chat GPT works, how you receive the responses, like how you actually get the output from those particular chatbots. Amazing thing. Then LM head, GPT, BERT and T5 models. Amazing chapter. React prompting. See, currently prompt engineers are in demand, okay, and you will actually know the reason why, because you do not know the power of prompts, okay, and you do not even know how many types of prompts we have. You will be say, hey, do we have types of prompts? Yes. Then we're going to talk about RAG, retrieval augmented generation, then vector stores, then practical coding. Yes, you heard it right. We're going to literally write the code to perform all of these things, and you will be like amazed. Do you need high GPUs? Do you need high computation? No, everything will be available for free, and all the resources, everything is available for free. Okay, with notes. Yes, with notes. Okay, don't worry, I will just also provide notes as well in my GitHub repo, and I will just show you the GitHub repo as well. Don't need to worry. Then we also gonna use pre-trained large language models that are already there. And in short, if you are someone, okay, if you are someone who is hearing so many technical jargon, so many technical words, keywords in the AI era, maybe on any platform, okay, because everyone is hearing those things, but you feel like let's study, but then you are not able to understand because there's not a structured guide for the data domain, right? Or I would say there was not, because now there is. So you need to be someone who is hungry enough to understand all of these things. And the best thing is, I will hold your hand, literally hold your hand, and I will be there and make you understand all of these things. Okay, are you the one who can just devote some time to understand these things? Advantage and promise that I can make with this video, that you will be able to understand all the things, all the jargons, all the concepts of AI that are required in the data domain. And after that, you'll be feeling like, now I know AI. Okay, now I can just dig deeper inside AI, because now I have the fundamentals ready. Because without fundamentals, you will start one topic and then you will take a pause. Why? Fundamentals are weak. I would say not even weak, zero fundamentals. Then you will start another topic, you will take a pause. Why? No fundamentals. You do not have a structured fundamentals in your brain right now, and I need to feed that in your brain. Okay, so let me just do that. Okay, and for free, enjoy. Okay, but just drop a lovely comment on this video, because I've literally spent so much of efforts so that you can understand AI. Okay, so let's make this video available to every lovely data family member, because I love my data family members. And let me celebrate the happiness, or you can say the achievements of my lovely data family members. So these are the recent offer letters that my data family members have cracked or received, and they literally make me feel proud. And so many congratulations. Okay, so there are more, by the way. Congratulations to everyone, then there are more. Congratulations to everyone, then there are more. Congratulations to everyone, then there are more. Congratulations to everyone. If I missed someone, so apologies from the depth of my heart, but you know, like, I love you a lot. Okay, there are more. Okay, congratulations. And finally, let me just talk about the thing that I just mentioned in the introduction, that you have a gift ready. These are basically the handles, first of all, that you can just follow me on these handles. Okay, and the gift is very special. I will just take 2 minutes. Okay, do not need to worry. So I got a special request from, I would say, beginner data engineers, intermediate data engineers, senior data engineers, that Ansh, we need a dedicated boot camp on Databricks. I was like, okay. I was thinking, and I was like, literally they need a boot camp which tells about Databricks from zero and take them towards the end and make them job ready so that they can just crack the interviews and just get their dream jobs, right? So I was like, actually they're requesting for the right thing, because if you are not aware about Databricks is the platform which is leading the AI and data space. And you can take this advice, okay? Databricks gonna lead this industry. It is already leading. It gonna lead the industry in the near future. So if you just want to make your career AI proof, obviously learn the AI fundamentals and also learn the Databricks technology as well. And now you have the resource ready. Finally, after months of efforts, okay, this particular bootcamp is ready here, and you can just go and check it out. You gonna enjoy, you gonna love it, and you gonna literally love it. Okay, because that is my personal favorite as well, because I have literally put everything which is available in Databricks, and you gonna become like job ready. Okay, and I will not take much time. If you just want to read or basically want to get more details, you can check my GitHub repo. Okay, everything is like all the information, notes, like everything is available there, and regarding this information as well. So I just wanted to give you a heads up to my lovely data family members who were requesting for this thing since so long. Finally, it's ready for you. Go and enjoy. And let's get started with this amazing masterpiece, because I know this is one of my favorite videos, and this video will actually make you AI proof and you will be able to understand all the fundamentals. Let's get started. Let me just quickly show you the GitHub repo where you can just find all the notes, all the code examples that we're going to follow, and everything that we have discussed so far. So let me just show you everything. So I have created a dedicated repo for this video so that you can make the most out of this video. So just go to GitHub, and I will also provide the link in the description, not a big deal, to the GitHub repo. So this is my GitHub repo, okay? And you can just click here and then go to repositories. So this is the repo, it's called Gen AI Guide for Data Domain, okay? And this is the repository for this YouTube video. Make sense? So just click here and you will see all the folders listed here, and notes, code example, everything is here. So just go and just make best out of this repo, and you will be just referring to these resources along with this course. Okay, make sense? So let's get started. So first of all, I want to ask this basic question, and you will be like, bro, we know what is AI. Really? Tell me what is AI. Because this term sounds like very familiar, but do you know what? When we just talk about, hey, when someone asks you, hey, what is AI? Can you just tell me what is AI? Can you define AI? You'll be like, AI is AI. So AI in a nutshell basically is a term, right? Is basically a name that we have given to a program. What kind of program? Obviously computer program or computer system. Now what's so special about that program that we have given the name called AI? Because we have written so many programs in the past, but we do not call them as AI. But why do we call some special computer programs as AI? Because just put some focus here, this word, because it can perform those tasks that require human intelligence. What? Human intelligence. Okay. Such as speech recognition, decision making, language translation, visual perception. All of these kinds of tasks actually are done by human using human intelligence. But when these tasks are or basically can be done by some computer programs, they are referred to as human intelligence. Okay, human intelligence. Okay, when this particular player or basically human intelligence can be mimicked by any computer program, okay, any, let's say you have written any computer program, okay, then it will become AI. That means artificial intelligence. I hope now you know the meaning of AI. You can ask me this question, how these can mimic the human intelligence? See, it cannot actually do the same stuff that humans are doing for now, at least. Okay, so now let's take an example of speech recognition. Okay, or let's say language translation. I am speaking English, you can understand English, right? So if your friend doesn't understand English, and if you want to explain my lecture to him or her, what you will do? You will explain or basically translate whatever I have said here to your native language that the person can understand. This is the task that you are doing using human intelligence, because you are trained on some languages since your childhood. Maybe you started learning English, obviously, in your school. You started learning A, B, C, D, E, F, G, blah, blah, blah. And obviously, your native language, it can be Hindi, it can be Telugu, it can be anything. So, you know those languages, right? You know those languages. So, you are trained, your brain is actually trained on that data. So, that is your intelligence. But now when we basically our program are trained on the similar data sets, they can also convert that language into human understanding language. Really? I wanted to catch you. Not really. So what it will do, this is special. This will not convert English to any language which can be understand or which can be understood by, let's say, any human. No, this is AI. This is artificial intelligence. So what it will do, it will convert our language, let's say now whatever I'm saying, into the language that machine can understand. Now what is that language that machine can understand? Who is saying French? Bro, it is just binary codes. Machine can understand only zeros and ones. Okay, only zeros and ones. Machine cannot understand English, Hindi, French, Spanish, whatever. No. So what AI will do? AI will convert my language into machine language, first of all, and then machine language to your native language if you're just using a translator. That's how it works. That's how it works in a nutshell. Okay, in a nutshell, because we want to understand so many things in deep using practical labs as well. So it is like very high level overview about AI. Make sense? Okay, so now you will say, Ansh, Lamba, we are studying about AI fundamentals, make sense, and nowadays we are just working with chat GPT, we are working with Claude, we are working with so many AI chatbots. So why do we need to worry about this thing? We need to learn about the stuff which is directly relevant to this. Bro, this is directly relevant to that. Okay, I know AI is used in so many other areas, robotics and blah blah blah, but this is directly relevant because AI is a big sphere. Within that sphere, you have a small area which is called as language AI. Exactly. You would not have heard about this term language AI because it is popularly known as NLP, which is called natural language processing. And you know what? I have just made these circles underline so that you can also take notes. Just take out your notebook and start taking notes. Okay. I know I will provide all these notes, but still write something, right? Write something. So language AI is the specific area within AI which is focused purely on language. When I was learning about these things, okay, when I was just reading some research papers, I was also unaware of this term because we didn't even hear about language AI, but language AI is the original name. NLP is the, you can say, popular name of language AI. Okay, so NLP, whenever someone asks you, hey, what is language AI, do not feel like, what is language AI? It is NLP, very simple. Okay, so natural language processing. Now I am so sure even if you are not a data scientist, machine learning engineer, you would have heard about this term NLP, and you would also have some idea that NLP does something with your normal language. Okay, and it converts that language into something else. Like it can literally do anything within your language, right? You would know about this thing, I'm so sure. So now you will say, what are the good examples of NLP? For example, this is like very practical. Let's say you have purchased a product on Amazon, okay, or any platform. Now you have just dropped a review. Okay, by the way, you should just drop a good review on this video as well, bro. I'm just doing so much of efforts for you, just for you, so that you can understand AI. And do you know what? Even if you do not drop a comment now, you will be forced to do that because this video is so good. I'm in love with this video. Just trust me, just be with me for more few minutes and you will just see that. Okay, so now let's say you have dropped the review. Now company or basically organization wants to know whether your review is positive or negative. This concept is called as sentiment analysis. Okay, sounds very fancy, but under the hood, what we are trying to do, we are just trying to read the comment, okay, read the review, and we are just trying to see whether this person is happy or not, right? If you will say, if I will just ask you to read the feedback, you will understand, hey, this is positive, hey, this is negative. Why? Because you have that intelligence, you have that intuition, you have that interpretation power, that you know, like, hey, I can just interpret this statement like this and it is like almost positive, like this, you know this. But again, machine doesn't have feelings, machine doesn't have anything. So now what is the solution for it? Solution is very simple. We have created a kind of concept called, or basically we have just worked so hard on a specific area within AI. It's called language AI, with the help of which we can actually process the language, like normal language, into machine code, and machine code can actually interpret, hey, this is the meaning of it, hey, this word like stands for this. You will be like shocked, right? Like how it is possible, right? But you know what, let me just give you a hint, okay, because I just want to just give you some hints. It is achieved, okay, through embeddings. You'll be like, hey, what is embedding? That's it, you just need to know this, okay? This is achieved through embeddings. We create embeddings, you understand the context about it. How we do that, don't need to worry, but just understand, just have those keywords. Why? You will be like much more excited about these things, and you will be aware that, okay, these jargons exist in today's world. But I'm so sure, even if I will not tell you these jargons, these are so popular and everyone is talking about embeddings, vector stores and all those stuff. So you need to understand all those things, right? So just a high level overview, we use embeddings, and embeddings is used to particularly, you can say, target this particular area, NLP especially. Make sense? Okay, now let's have a quick review of the history of language AI, like how it started and how it is currently doing. Then we need to go deeper inside each one. Why? Only then you will be able to understand the current, you can say, understanding or current structures that we are following in the industry. Otherwise, you will be just remembering and learning the stuff, you will not be understanding the stuff. So but my responsibility is, especially for my lovely data family members, I want you to understand the concept, like how it started and how it is like evolving. Okay, let's see. Now let's have a quick look over the evolution. Okay, don't worry, we wanna just go very much in deep in each kind of, you can say, evolution that we are seeing, and everyone is important. Do not feel like nothing is important except this one. This one is not very important, but do not forget, like, this was the beginning of like creating embeddings and all. Okay, so do not feel that this is not important, everything is important. So let's start with early 2000s. And what is this called of, what is this called, BOW? So let's say if we have a text, if I have an input, I want to apply NLP, okay, natural language processing. I obviously need to convert that particular text into a language that machine can understand along with its meaning, because the end goal is simple. We have a text written in maybe, let's say, English, and because English is like very common language, so let's say it is written in English. The end goal is we need to convert that text into a language that machine can understand. This is the end goal. So what we were just trying to do, we were following a concept, or basically a process. It's called bag of words. Bag of words. Now, what is bag of words? Do not worry, we're going to talk about that as well, very much in detail. Okay. In short, just to understand the concept, bag of words is basically the process where you, so let's say you have a sentence. Let's say you have a sentence called, what is the sentence? Let's say, I love bikes. Okay. Really? I don't know. But yeah, let's say this is the sentence. I love bikes. Make sense? So now I need to understand the meaning of it, right? So what I will do, I will first of all separate each word. Okay, each word. Let's say I love and then bikes. Make sense? So I will just do that first of all. Again, we're gonna just talk about the whole process in detail, but I'm just giving you a high level overview. So let's say I want to just separate all the words I love bikes. So what I will do, I will simply create a bag and I will put all the words within that. Then let's say there's another sentence. Let's say I love, let's say you love someone. Okay. So now what will happen? We will just try to figure out the meaning or basically the numbers associated to each word. How we do that? Just a quick recap or basically quick you can say preview. So what we do, we simply count the occurrence of each word. How many times this word is occurred from this bag of words. If it has occurred 0 times, we will simply write 0. If it has occurred 1 time, we will write 1. If it has occurred 2 times, we will write 2. So let's say love has occurred 2 times. So we will simply say love means 2. So we create the vectors like this. Again, not very efficient method and you will know why, okay, very soon. But this was the initial method of converting your text into numbers, okay, basically in the embeddings. Again, I'm repeating this word embeddings because this is the backbone, okay. But for now you do not need to understand embeddings. Just feel like whenever we convert a text into numbers, okay, we call them as like embeddings, okay. So BO, that means bag of words, was the very first process to convert a text into numbers. Make sense? Then after that, we got something called as word to vec, and this was very good. This was literally very good. And you will see the practical lab of this as well. Why? Because word to vec is still relevant. It is not like it is totally gone. No, it is still relevant. So I will just show you the code as well for that, how you can just convert your text into numbers. Okay. So word to vec was introduced around 2013. So in word to vec, what we try to do, again, we try to separate each word, okay, from the sentence, and then we find the meaning of each word. That means you, okay, you love someone, I don't love someone, you love someone. Let's say you love someone. So I will find the meaning of you, I will find the meaning of love, no meaning. Then I will find the meaning of someone, okay. Let's say XYZ, okay, and you can just imagine your favorite person, okay, that you want to imagine, but just feel like what I'm just trying to say. So we will just find the meaning of each word. Let me just write it for you because I know like you connect better when I will just write something. Let's say you love what? Anything, man, XYZ. Okay, so let's say this is you, and let's say blue. Okay, so let's say this is you love someone, okay, you love someone, and vice versa. Okay, if this is you, then you love someone. If this is you love someone. Okay, so you, or XYZ, you love XYZ. So what we will just try to do in word to vec, I will try to find the meaning of you, I will try to find the meaning of love, and I'm still trying to find it out, and I will try to find the meaning of XYZ. So this way we have the meaning, literally the meaning of each word, and that's how we can efficiently convert the sentence into the form of numbers. Now you will say, Ansh, Lamba, how we can just create or basically find the meaning of each word? It is very simple. It is very simple. You will see it. Just be with me. I will just show you the code as well. It is very simple. Okay, and I will just provide you the notebooks as well, and everything is for free because we're gonna use some free softwares. Okay, so you do not need any kind of fancy laptop, fancy computer. You just need hunger to learn. That's it. Okay, and this guy will handle everything else. Okay, then let's say after word to vec, everything was working fine. Okay, then we initiated something called as attention. Attention. This is the game-changing thing. Attention. When we got attention, we were like, woohoo, it's a big win. Yes. And after attention, after 2017, how it works, do not worry. I'm again telling you, I'm going to just tell you everything in detail. So after attention, okay, attention mechanism, we are using everything right now. Okay. And it is called GPT models. What are GPT models? Do not worry, my lovely bro sisters. Do not worry. GPT models, BERT, and then T5. Basically, these are the popular machine learning, or basically not machine learning, deep learning models, which are called as language models. Okay, we haven't touched language models yet, so do not worry about that. It will be covered very, very soon. For now, we do not know what is language model. Just forget about it. We do not know language model, but we will learn it. Okay, don't worry. So GPT, BERT, T5 are some popular models in the market right now. Okay, they are totally based on this particular thing called attention. It is called attention mechanism. Make sense? Perfect. We do not need to understand GPT for now. We do not need to understand BERT for now. No. We're gonna learn step by step. Otherwise, you will be confused and you will be like banging your head in the walls and you'll be like, what is this AI? Do not worry. Learn step by step. Okay. So this was like complete evolution so far because I want to give you that insight that what's going on currently. Okay. So now I know you are really excited to learn more about embeddings because I have used that word multiple times. Now let's see what are embeddings. Okay. What exactly are embeddings, and let's see what are embeddings with this concept, like obviously one by one with all others as well, but let's start with this one. Okay. Let's see. So now let's try to understand what are embeddings finally. Okay. So see how quickly you are ready to understand embeddings. Okay. And this is one of the most popular, okay, most popular and mostly used concept in today's AI world. Once you understand this, you can literally understand so many things that are just revolving around you right now. Okay. So let's try to understand what are embeddings. Let's read the definition first of all. Embeddings are vector representation. Ansh, Lamba, stop here. Wait. Embeddings are vector representations. What are vector? So now, if you haven't studied mathematics in your class 11th, 12th, if you haven't studied physics in your in your class 11th, 12th, you will be unaware of this concept vector. That is why we say if you just want to grow in AI world, you need to understand these concepts, vectors and all. Okay. You do not need to do PhD on those things. I also studied like vectors long way back. Even I just did my bachelor's in mathematics. Still, I'm not a master of vectors, but I know what are those things. Okay, I know that. Basically, there are two concepts: scalar and vector. Scalar and vector. Scalar is let me just explain you that concept in just 2 minutes. It's not a rocket science if you are not from mathematics background, because I know in my classroom as well, like all my friends were in like commerce without mathematics. Ansh, Lamba was in non-medical. Wow. So I was like, okay, we are not the friends now. Okay, so now let's say there's a bike. Okay, you are, let's say, riding a bike, and the speed of the bike is let's say 30 kilometer. Oh bro, we just drive very fast. Let's say 60 kilometer. Like, okay, good, happy, very good, very good. You're doing a great work. So 60 kilometer per hour. Let's say you are just driving your bike. This is a concept which is called scalar. Why scalar? Because I actually do not know the direction, in which direction you are driving. I just know that you are driving your bike at 60 km per hour. Let's say you are driving towards east. You are driving towards west. You are driving towards north, south, whatever. Whenever we just add, you can say, directions with that. Okay. It becomes vector. It becomes what? Vector. Basically numbers with directions. That's it. Under the hood. Okay. So now, when we say embeddings are vector representations, and if you do not trust me, let me just show you, bro. What are vectors? Vectors. A quick mathematics class, because I want to just you to understand everything. Okay. You do not need to worry about any prerequisite, because I promise that there are no prerequisites. But if I feel like you should know this concept, it is my responsibility to make you understand the concept. Okay. So let's say images. So types of vector. See, this is a very good example. So by the way, Geeks for Geeks, amazing work. You are doing amazing work. So this is their, you can say, example. So what they, let's say X and Y, and we always denote vectors with the arrow sign on top of it. Okay. Now why vectors are important? Why? Let's say you and your friend both are driving bike at 60 km per hour. Okay. If we do not have vectors, we actually do not know in which direction your friend and you are going, right? Maybe both can go in the same direction. Maybe both can go in the opposite direction. Maybe both can go wherever they want. Okay, so if I just want to find the distance or similarity between you and your friend, I cannot do that. So just see this. If let's say you and your friend are actually driving the bike in the same directions, it will be like this, right? In the same direction. But if you and your friend are driving bike or whatever in the opposite direction, that means one is going this side and one is going that side. So whenever we just attach the direction with the numbers, it becomes vector. Okay, and that is the information that you need. Other than that, you do not need much. Okay, so that is fine. That is fine. But now you would understand and feel the embeddings. Otherwise, you would not be able to feel the embeddings, because I'm gonna explain you some amazing examples, and you will be like, Ansh, Lamba, love you, bro. Yeah, love me as a bro. That's it. Okay. So now, what are embeddings? Let's continue. Embeddings are vector representations of words. That means, let's take that example. Let's say you love someone. Okay. So let's take the word someone. Now what I will do, I will first of all try to find out the number of it. Let's say this number is assigned as 10, let's say. Okay. But this 10 number will have some direction as well. Okay, 10 in this direction, 10 in that direction, 10 in that direction, and whatever. Makes sense? So embeddings are vector representations of what? Words. Words that attempt to capture its meaning. So let's say we want to capture the meaning of this word. That means this will be my vector representation. Okay, this is like a hypothetical situation. This is not a vector representation of this, because we have so many coordinates, we have so many parameters and dimensions. But just for the simplicity, you can take this as an example, because under the hood, this is also a vector, right? This is fine. Now, they are numerical representations that allow machines to understand and process human language. So now when machine will take this word called someone, machine will not take this word someone, it will use this thing, because machine can understand the numbers, machine can understand like in which direction it is going. We can use mathematics. Do not worry about that, because you are not going to write those mathematical logics, because now the libraries and functions and models are already built. But yes, ML engineers, researchers have actually did that hard work for you. I've actually done that hard work for you. Okay, good. So now, what did I say? That allow machines to understand and process human languages. There are different ways to create embeddings. Okay, there are so many ways, and you have just seen like some of those. Okay, so first of all, BOW, bag of words. Then we have TF, IDF. Then we have word2vec. Then we have Glove. Then we have BERT. Then we have GPT as well. So we have so many things. We have T5 as well, but you do not need to worry. Okay, because we're gonna learn everything step by step. Make sense? So now you have, I think, some visual understanding about embeddings. Visual understanding. So basically, let's say your name is, let's take the real example, bro. Let's say your name is Rahul. Okay. Let's say your name is Rahul. Okay. So now machine will not understand like who is Rahul. But when you convert this Rahul into embedding, machine will understand, oh, Rahul is this guy in a good sense. Okay. Rahul is this guy. So no offense to any Rahul here. Okay, just a hypothetical situation. That's why I do not take like real examples, man. You will be like, hey, why are you just talking about Rahul like this? Personally, I do not know anyone, but so now you understand the concept. Make sense? Very good. Now we are good to understand the very first, you can say, model or technique that we used to follow about for embeddings. It's called BOW, bag of words. Do you know what? Yes, it was started in the industry around early 2000s or 1990s, but actually it was created around 1950s. But it gained popularity around 2000s or 1990s. Okay, bag of words was like one of the first examples, and I just want to explain you everything like step by step. So actually I have a real-time example that I want to display in front of my screen, so that you can understand and you can take notes for this, because obviously this is a live example, so that you can understand all the things live, because I know you'll be like, hey, how we can just do this. So basically, let's say you have a bag of words model, and somehow you are using that model and you are able to translate your word into the numbers, into the vectors. Now you need to understand how this particular system or this particular program is doing that. Make sense? Understood the situation? Okay, makes sense. So let's say I have the input here. Let me just write it for you. And again, this is live example, so you have to take notes for this. And when I say you have to, no negotiations. Okay? Because this is not like just a normal video where I'll be just pasting all the text, blah, 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 blah. No, this is a live session, kind of live session. Okay. So now if I'm just putting my efforts, so I would expect some from you, because see, it is just for your benefit, right? What I will get if you just take notes or not, I will feel happy if you take notes, because I know it will help you a lot in future. That's it. So let's say you have a sentence called, let's say, that is a cute cat or cute dog or any animal that you love. Let's say that is a cute dog. Very good. Okay. Then let's say there is another sentence that, let's say, called my cat is cute. Let's say, like anything. Okay. Let me just put it in the next line. My cat is cute. Okay. Let's say these are the two, you can say we have the sentences. Whenever we just create the program for embeddings, do you know what is the first step? What is the first step? Training. We want to train the model. So for example, when you were born, okay, you were trained, your brain was trained on words. Hey, say mama, hey, say papa, whatever training you got, right? Whatever training you got. You didn't get the training, hey, what is a vector? Obviously. But you got some training. Hey, say this, say that. So you got the data, right? You got the data. Whenever we create any program, any embedding model, we first need to train the data. Basically, train the model with the data. Make sense? Make sense, everyone? Okay. Very good. Now, what will happen? What will happen? Everyone, listen to me carefully. Okay. So what will happen? We first of all train our data. Basically, train our model with data. And how we do that? Obviously on the basis of data that is available everywhere. And what is that textual data which is richly available everywhere? Is there any word richly? Because I just used it. So the answer is Wikipedia. So most of the models, or I would say most of the initial models, were trained massively on Wikipedia data. Okay. All the Wikipedia data. So what we do, we simply create a kind of bag of words. Okay, bag of words. So let's say this is my bag. Okay, and here I have words. Let's say this is a word. Let's say this is a word. Hey, let's say this is a word. So there are like so many words. Okay, there are so many words in this bag. Now, how this bag is created? How this bag is created? Do you know? You know the answer, just think about it. Just think about it. So basically, the first step is tokenization. This is a new concept, but the concept is very easy. Tokenization. Okay. Tokenization. Remember, I just asked you like, you can separate each words of the sentence, or basically each word of the sentence. This is called tokenization. This is called tokenization. So let's say this is a word, this is a word, this is a word, this is a word, this is a word. These are all tokens. In the AI world, we just call them as tokens. Initially, each word was represented as a token, but as like we evolved, we started basically creating multiple tokens from one word. A good example, don't worry, we are not discussing that thing, but just for the understanding, let's say this cute word will have two tokens, such as CUT and E. Okay, because now we have like richer models which have like more context. Okay, but initially, or just for the simpler understanding, you can treat each word as a token. Okay, do not need to make things complex. Okay, no, I'm here to just explain you everything, don't worry. So first step is tokenization. So let's say we have so much of Wikipedia data. Okay. And just imagine for a moment that this is all the Wikipedia data that I have. let's say this is all the Wikipedia data that I have. Make sense? Make sense? Okay. So now what I will do, I will create the tokens. That is a cute dog, then my, then cat. That's it. Wow. Why didn't you pick is and cute? Because in the bag of words, we do not repeat the words. We will simply take the unique words. Okay? Unique words. That's it. So what will be my bag? Okay. What will be my bag? So my bag is something like this. That, or let me just write it here. Okay. So that is my bag. That is a cute dog, my cat. That's it. This is my bag of words that I have on the basis of the text corpus that I have. And we are just assuming that this is the text corpus that we have. That's it. But in reality, in the models, we have like so much of big text corpus, like using all the Wikipedia data. But just imagine like this is the very first step. Okay. So this is our vocabulary. This is called as vocabulary. Vocabulary. Very good. Or basically the entire vocabulary of our bag of words. Now what will happen? What will happen? So this is actually the entire vocabulary. Okay. Now let's say there is a new sentence. There is what? There is a new sentence. Okay. Now what kind of sentence it like is it? So now let's say I have given the input like this. The input is my, or let's say I love XYZ. Okay. But this will be like not very relevant. Let's say I am cute. Not I am, let's say you are cute. I know like you will say, oh, really. Let's say you are cute. Okay. So let's say this is the input. I am cute. Okay. This is the input. I am cute. Now I want to find the embeddings for this. Do you know what will happen? So it is very simple process. So let's take a new example. The reason is very simple, because if I will just take that example like I am cute. So basically in the real world, in the vocabulary, we have almost all the words that we use, right? So that is why I just want to take an example in which we have all the words available in the vocabulary. Make sense? Because see, in the real world, the models are trained on the Wikipedia data. So they have almost all the words that we will be just using, right? So let's say I will take the sentence, for example, dog is cute, something like that. Let's say dog is cute. Okay, that's it. Let's say this is the example. I hope like that is clear, like why I'm not taking the previous example, because we do not have I and am here. But in the real world, we usually keep all the vocabularies. Okay. So there are two ways. Either we can just change the example or we can increase the vocabulary. Okay. And I don't want to increase the vocabulary because your brain is actually following the same example. So let's change the example. Okay. So now what will happen? It will create the vector. And how it will create the vector? It will create the vector on the basis of the occurrence. For example, it will simply start the vector like this. Let's say like this. And then it will simply say, is there any that available in the input? No. Okay. Is there any, you can say is available? Yes. Okay. One. Is there any A available? No. Cute? Yes. Dog? Yes. My? No. Cat? No. So this is actually the vector representation of this particular input based on our vocabulary size. So Ansh, Lamba, if we have more words or basically more like bigger vocabulary, so bigger the embedding vector. Okay. Common sense, right? Do I need to answer this? Obviously, yes. So if I have the bigger vocabulary size, I will be having richer embeddings. Okay. The vector size will be much bigger. Make sense? So this is all about bag of words, like how it works and how we just create the vectors. Make sense? Okay, just occurrence of the word, that's it. And just a quick note, whenever we just create a vocabulary, for bag of words, we also use something called as lemmatization and stemming. Basically, these are the strategies to create the effective vocabulary size. Why? Because whenever we just create the vocabulary size, we do not want to put like common words like ing. Let's say dog is running, so instead of just storing running, it will simply store run, converting the continuous tense form into simple present tense like this. So these are some of the techniques and strategies that they used to follow, because nowadays we do not use bag of words much, but this was the very first approach of creating embedding vectors. Make sense? Now, Ansh, Lamba, what is the problem with this? Like, this is very good. Not really. Because this particular strategy, this particular technique is treating our input as like just a bag of words, like no importance on the, you can say words, like how they are just represented, how they are just repeating, how they are just portraying the context. So it doesn't even have any context, no efforts on specifying like what should be there. For example, dog is cute. If I will say, is that dog cute? Or let's say, is dog cute? Same embedding. Why? Because words are exactly same, right? And it's not just about words are same. Second thing is, each word doesn't have its own meaning. See, I am simply saying if dog present here in my vocabulary, yes, I will simply say one. That's it. I do not have any kind of vector which will tell me dog means this vector, cat means this vector, cute means this vector. I want to know the semantic meaning of each word. Is it possible? Obviously. And we're gonna just work with that strategy very, very soon. It's called word to vec. I'm just giving you a hint. So we now need to find the meaning of each word. We are just not concerned about is that word available in our vocabulary or not, or basically is that word is that input available in our vocabulary or whatever. So let's say here we do not have cat, so we simply mentioned hey 0. So we are not actually capturing the meaning. I want a vector for this thing. I want to know what is the meaning of dog. I want to know what is the meaning of cute. Make sense? So this is the second step of our, or not second step, basically this was like one of the biggest strategy that we are just currently following. Okay, it is called word to vec, and word to vec was, I think, started or basically initiated by Google. So we will just talk about word to vec obviously in the dedicated chapter, but I'm just giving you some hints, okay? Because this is just about bag of words, which was the very first technique to create the vectors. But yes, it was a hit one in the early 2000s, or basically in the late 90s, okay? So it was a big hit. And then we obviously saw so many advancements, okay? And now let's talk about those as well, okay? Let's see. So now let's try to understand word to vec. And let me just give you some context. Word to vec is still used in so many areas, so do not feel like bag of words like something that is not used much now, but now you know the basics of it, embeddings. So now you can understand word to vec. If I would be just explaining directly word to vec directly to you, you'd be like, huh? So that is why now you know, okay? So now what is word to vec? As the name suggests, word to vector. Short form of it, like obviously it is not officially written, but common sense, word to vector. What is this thing? I will say again, the end goal is same. We have some input. Let's say input is cat is cute. Okay. We need to find the meaning of it. But this time I said like word to vec is advanced technique which calculates the semantic meaning of each token, basically each word. Now you know the token as well, okay? So it knows how to find the semantic meaning. Make sense? Make sense? Okay. Now, how, let's say we want to find the meaning of cat. How we can just do that? How? What is the meaning of cat? Do you know what? What2vec uses the dimensions, or you can say vector representations of 300 features, or you can say 300 dimensions. Now, what are these things? Okay, what are these things? So I will, and I'm just explaining you this from the layman perspective so that you can understand the concept. I will evaluate this word called cat. Okay, this is my word. Let's pick this color. Let's say cat. Okay, and I will be having some dimensions. Dimensions are just the fancy name for features. Let's say I have some features. Let's say one feature has tail. Okay, second feature is color. Third feature is weight. Okay, fourth feature is like so many features. Okay, let's say animal, okay, mammal, whatever. So dot, and I have 300 features. Okay, total 300 features. I will evaluate. I will what? I will evaluate the score of cat based on these 300 parameters, or you can say 300 dimensions. So what I will get, let's say cat has tail, yes, but not much big. Let's say 0.8. So we will just try to give the numbers between, like you can obviously give the numbers between minus infinity to infinity, but just for the sake, you can say we can just provide the number between the scale of, let's say, -1 to 1. Okay, just -1 to 1. Okay, makes sense. Okay, good. So let's say 0.8. Color, let's say 0.1. Okay, weight, let's say very less, let's say 0.3. So this way it will have the score. Okay, score. If I just need to combine all these 300 features, can I say this, that the final vector will have 300 features or 300 dimensions? Can I say that? Okay, so let's say 0.8, 0.1, 0.3, and so on. Let's say the last one is, let's say 1. Okay, so I have 300 dimensions. So now this cat has this vector. Okay, let me just use yellow color. So let's say this cat has this vector. Okay, this vector. That means cat has this meaning. Cat has this meaning. Makes sense. Now let's say I have another word called dog. Let's say, okay, I have another word called dog. I will do the same stuff, and what I will do, I will simply try to evaluate it. So it will be, let's say, has tail, yes, and it has some obviously longer tail, so 0.9. Color, let's say 0.2. Weight, obviously more than that. Animal 1, and blah blah blah. So many other things, right? So this way I will have 300 vectors, obviously, right? 300 vectors. Let's say 0.8, not 0.8, 0.9. Okay, 0.2, and so on. Okay, so this is also of 300 size, like 300 dimensions. Make sense? Sorted? Very good. So now this cat word has this meaning. This dog word has this meaning. Okay. So in short, what we did, we simply evaluated it. So basically on the left hand side, I have the features, 300 dimensions. And on the right hand side, I have the words, basically words. And each word is evaluated for each of these 300 dimensions and has got the score, in short. This way, computer knows the meaning of each word based on the scores it has got for each 300 dimensions. Obviously, now this cat word has a meaning. This dog word has a different meaning because this has a different vector, right? This has a different vector. Make sense? Make sense? Okay, makes sense. So now just tell me one thing, because Ansh Lamba, you said that if we, let's say, want to find the similarity between the words, how we can just do that. And you said about cosine similarity as well. What is that? Just let us know. So for example, let's try to draw these vectors. Obviously these are like 300 dimensions, so I cannot just show you like 300 dimensions. I can only show you 2D, that means 2 dimensions, right? But let's say we have 300 dimensions. 300, you can just imagine the space. Okay, 300 dimensions. So let's try to plot these two vectors. So let's try to draw both the, you can say, vectors. Now we have vectors. Okay, let's say this is the dog vector, this is the dog vector. Wait, let me just fix this mic. Okay, now it is good. Okay, so now I have dog vector, dog, open your mouth and shlama, dog. Yeah, 0.9 and 0.2 blah blah. Okay, so this is my dog vector. Then I have cat vector, right? Cat vector 0.8, 0.1 and blah 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 blah. Okay, so these are the two vectors, right? So let's try to draw these two vectors. So let's say I have this graph, and obviously 2D graph, but in reality they will be like 300 dimensions. This dog is somewhere here, okay, in the space. Okay, this cat is somewhere here, so let's say here. Okay, let's try to draw the lines. So let's say this is here and this is here. Okay, so these are the plotting of these two vectors. Now in order to find the similarity, we use a concept called cosine similarity. What is cosine similarity? If you have studied trigonometry, and bro, do not say we didn't take mathematics in 11th 12th. Trigonometry is a like 9th or 10th class concept. Remember cos theta, tan theta, sin theta and cosine theta, sec theta, all those things, right? Okay, right. So now obviously we are not going to just study trigonometry, but just a common thing. So in order to just find the similarity, like how close these two words, because we in reality we know cat is very similar to dog, right? You will say, really? Bro, I'm just talking about from the broader perspective. Obviously it is more related to dog, like cat is more related to dog. If I compare cat with, let's say, house, is it related? No. So obviously cat is more related to dog, right? So how it will just find that? So let's say this is cat and this is dog. Okay, this is cat. Ooh, this is cat. And the angle, we will simply find the angle between both. So let's say the angle between two is 45 degree. Okay, 45 degree. So what we will do, we will simply find distance. Basically, obviously, what is the end goal? We simply need to find this, right? We simply need to, let's say, find distance from dog to cat, right? We need to know like how close these 2 points are, right? So distance formula says 1 minus cos theta. Okay, and where is the symbol of theta in my keyboard? I don't know, so you can simply say cos theta. Okay, cos theta, 1 minus cos theta. So it will be 1 minus cos 45. Okay, cos 45, I think it's like somewhere around 1 upon root 2. That will be somewhere around 1 point, not 1 point, like 0.7, because 1 upon root 2 is 1.4, 1 divided by 1.4, 0.7. So it will be like this, and it will be somewhere around 0.3. Okay, so distance is 0.3. It is closer to 0, right? So that means they are close to each other. That's how word to vec can identify how close two words or tokens are, because they are closer to each other. Let's say at the same time we have another word called house, and house is plotted somewhere here because house doesn't have any tail and all those things. So let's say this is house, and if I just try to find out distance between, let's say, house to dog, it will be like very difficult, because it will be like very big theta. Okay, very big angle, somewhere around, I would say 90 degree, kind of, because it is almost perpendicular. Okay, so cos 90 I think is 0 degree, and it is like almost opposite. It is almost opposite. Okay, because both are perpendicular. So distance is 1, that means like closer to 1. That means they are not very much close. Let me just find the cos 90, otherwise we'll say, hey, this boy has done bachelor's in mathematics and doesn't know Cost 90. I think it is 90. Oh, sorry, 1, like 0. Yeah. See, I remember those things. But do you know what? I didn't study this in my bachelor's. This was like class 9th and 10th concepts. So now you know how you can just find the distance between those worth those tokens. Now, do you know what I want you to do? You need to draw the same graph that I drew just now. Why? Because you will understand the concept. You will have that thing in your mind. Now, a quick note. You will say, Ansh Lamba, how do we train this model? How? Because obviously we need to find the score. Let's say cat has 0.9 score for tail or color, whatever, right? So how we just train this model? So there are basically two techniques, okay, very popular ones. Continuous bag of words, CBOW, okay, and second one is skipgram. So basically there are two architectures, okay, both are like very much similar and very much opposite, because one just hides one thing and one just displays the other thing. Obviously you do not need to go into like how word2vec is trained, because word2vec is built now by researchers, by ML engineers, all of those people. Now you need to simply use it, right? Simple. Simple. Okay. Are you excited to just convert your text into numbers, and you want to see like how those things work? If yes, do let me know in the comment section right now. Because if you say yes, I will show you the code that you will also be able to run it. If you will say yes. So I want to see like who will say yes. Okay. Okay. So are you ready? Okay. So now let's try to convert, because this is fun. You are my data engineer. You are my lovely data engineer. And I love you a lot because I want you to learn everything. Okay. With practical labs as well. So what I'm going to do right now, I will just take you, okay, to my code, and do not worry, you will also build that code, because I will just share that environment with you, and you will write that code, and you will be able to convert each word, basically each word, okay, each word into embeddings. Fun, a lot of fun, right? A lot of fun. Okay. Obviously, we are not going to train this model because this model is already trained. We will be using GenSim if you want to know. Okay. So we'll be just using GenSim model, and we do not need to worry about anything because already the model is trained on the large corpus of text data and using continuous bag of words, using skipgram architecture. We just need to use that model to convert our each token or word into 300 dimensions vector. Simple. Now let's see how we can just do that. So now, in order to work with, first of all, let me just remove this cost 90. You will be just running away from this. I know, like, I don't know, like, why people just run from maths. It's so much fun, right? Cos theta, tan theta. I love those days. Like, those were the golden days when I just used to take my register, my notebook with me to tuition, and we were just like solving these 5 pages, 10 pages of questions on trigonometry. Fun, man, fun. Okay. So now let's solve the bigger problems in life. Okay. Trigonometry is solved. Actually not solved, but yeah, still. So now what we're gonna do, we need to write our code, and obviously in order to work with deep learning models, you need high GPUs, you need high computation power. Okay, you'll be like, Ansh Lamba, I do not have that laptop. Even if you have that laptop, it's not very easy to work with those environments, because you need to just download those models and you'll be just managing those models, and you'll be just, it is like heavy. Okay, a good thing, all thanks to Google has, if you are unaware of this, because I was also unaware of this when I was just learning all these things. So let me be very honest with you, because you are a human being, right? You need to know things, right? Someone will tell you, then only will you will be able to understand, or you will read something. So let me just tell you about that. So Google has just launched something called as Google Colab. Do not say, Ansh Lamba, it was launched few years ago, but still, when you are exploring, it is new to you, right? So same thing. So Google Colab is the environment. Have you ever used Jupyter Notebook? Have you ever in your life Jupyter Notebook? If not, bro, what are you doing? You haven't used Jupyter Notebook. Oh man. So basically Jupyter Notebook is the notebook that we use to write pandas code, numpy code, all those things. Okay. So let me just show you Jupyter thing. Maybe you would have used that and you do not remember the name, because I know you are very, very busy with your favorite people, whatever shit. Okay. Jupyter Notebook. So let me just show you the images. Okay, so this is a Jupyter Notebook. See, this is a Jupyter Notebook. So you would have used this, right? Okay. So now we use Jupyter Notebook, but not on our machine. What do you mean? So when you just want to use Jupyter Notebook, you download it and you run it on your server, right? Yes. But now Google has done something. It has hosted Jupyter Notebook on their server. So that means whatever you will be downloading, let's say you download a model, let's say you download or basically upload any data. So do you know what will happen? They will allocate you a virtual machine on the fly. Okay, when you will be just creating the notebook, they will allocate you the machine, virtual machine, free of cost, and they will allocate you some memory. Okay, obviously memory means like storage, not RAM but storage. Let's say 60 gigs, 70 gigs, 80 gigs, it depends. You will get that storage also for free to download your models, because most of the models are really, really big. Let's say 5 gigs, 10 gigs, 20 gigs, 30 gigs. Okay, so you will get that memory as well. Along with that, you will get the CPU, that means computation. You will get GPUs as well, literally GPUs. Do you know GPUs are so expensive? You can literally, because in order to run deep learning models, you need GPUs. Okay, so it provides you that as well. Basically, this is a virtual machine that has everything that you need for free. So very thanks to Google. And because of these big tech giants, like I don't know like why people just curse these big tech giants. They're actually contributing in the community as well, so that you can learn and grow. So how you can just get started with it? You need to simply search Google Collab on Google or Edge. Okay, I would say Google, because Google, whatever. Search it. Okay, you will find the first link here, Google Collab. So what it will do, it will simply open this similar kind of interface. Maybe in your case, you will see white screen. I'm seeing dark screen because of my theme. So what is the agenda of this? Welcome to Collab or blah, blah, blah. Simply click on cancel. And this will be your demo notebook or default notebook that you will see. Make sense? Good. So now what is the agenda of it? So this is the kind of Jupyter interface, right? If you can relate to it, this is a Jupyter notebook. See, this is a cell. Then this is a cell, this is a cell, so many things, right? So you can literally create notebooks on the fly. Okay, you can connect that notebook with the Google server, not your own server. So you can see connect button. So this connect button means you can connect this notebook to the Google server. Some people will say, what if we want to use our own laptop because we are so rich, we have like super computers available, bro? So you can use hosted runtime as well, if you, or basically connect to a local runtime if you just want to use own machine. I don't know what is the reason of using your own machine instead of using Google servers, but if you want to, you can. But I know my data fam will not be using this even if they have powerful computers, because it doesn't make any sense. Okay, why to waste the computation and all, and why to just worry about maintaining all those things? So what I will do, I will simply create or click on this file, and I will simply say new notebook in Drive. So do you know what it will do? It will create a notebook in my Google Drive. Oh, okay. So it will save the notebook automatically in my Google Drive. And where it will save it? You can check it here, go to file and go to locate in Drive. When you will click on it, you will land on the dedicated directory for it. So notebooks are saved in your Google Drive, whatever account is linked to that, obviously common sense. Okay. So now this notebook is empty. Nothing is there. Let's try to give a good name here. So let's say what to vec. Make sense? Okay, good. Word to vec, and it is like auto saved. So whatever you are writing, it will be saved automatically, but you can still hit Control S. Let's say I am ready to write my code and I want a virtual machine. Okay, so simply click on connect button, and within a few seconds, you will see that your notebook is connected to the server. Okay, let's wait for a few seconds. Can you see RAM and disk? That means your system is connected. And how you can just see that? If you click here, table of contents, not table of contents, maybe this. Yeah. So this is the area where you are seeing sample data. What is this? This is the storage. This is the Google storage. Okay, this one, where they have uploaded some sample data set so that you can just try and test so many things. If you expand it, you will see some JSON, CSVs, or all those things. You can literally use it. Okay, you can use it. Okay. Now, what is the space of this computer? Currently, I have 68.59 GB disk available. That means it can be hard drive, it can be SSD as well. Okay. So I have this space available. Now some people will say, Ansh, forget about word to vec for now, because we are so happy to see this. Let's say we want to practice Google Colab for our own projects. Can we upload our own data here? Yes. Just click here. Okay. Upload to session storage. It will upload your data here. Literally here. Okay. Counter question. Will it be there for like ever? No. So what happens Currently, this is connected to this RAM and disk, right? And I said that this notebook will be saved in your Google Drive. Make sense? But you know what? The moment this notebook session is disconnected, that means maybe timeout is done, maybe because there is like some idle time. So that let's say if you're not running any code for 15 minutes or 20 minutes or 30 minutes, okay, you can just check the exact time. So this notebook will be disconnected and that virtual machine will be released. And obviously use your common sense. Now what you have? Only the notebook in your Google Drive. So let's say tomorrow you come and you want to use the same data, it will not be there. Why? Because that virtual machine is released and your data was saved in that virtual machine. That means here. But the moment it is released, it is gone. So that is why it is a kind of little drawback, okay, that you have to upload your data every time if you just want to work with this with your projects. Second good alternative is you can use this button called Google Drive. Basically, you can mount your Google Drive with this particular notebook and you can use the same code. Choice is yours. Make sense? You can literally read this data if you want to. If you just click on these three dots, you will see copy path. And if I just paste the path here, you will see everything here. Make sense? Make sense? Sorted? Okay. So this way you can work with, you can say, your data if you want to. If you just, let's say, want to analyze some data using pandas, whatever. Now, quick question. Do we need to install pandas and NumPy and all those things? No, because this is specifically built for AI. Okay. And they know like they'll be using Python a lot. So some of the popular libraries and packages are already installed, such as pandas. So if I write import pandas as PD, and if I run this, and how to run this, simply hit shift plus enter, or you can even run this button. Okay. I will say shift plus enter. So it is done. It didn't throw error because pandas is already there. So let's say if I want to read any file, .read CSV. Okay. So I can simply paste the path here and I can say df.head. Obviously this is not a pandas class, but I'm just showing you that this way you can read the data and you can do your data analysis or anything using Google Colab, even if you do not have any environment setup. So no excuses to your learning. Now let's get back to our point because this quick tutorial of Google Colab is done. Very good. So now what we want to do, we want to install a word-to-vec model, which can just convert our data into text. And we'll be using GenSim. Now what is GenSim? Let me just show you. GenSim word-to-vec. Models, word-to-vec, embeddings, word-to-vec with GenSim. Basically, this is a model that is trained on some data, okay, and that we can just use to convert our data into embeddings, okay. Do not worry about code because we have everything, and that's how you can just create all of these things. Training word-to-vec model with GenSim. If you just want to train word-to-vec models with GenSim, if so, there are all these sentences. That means your vocabulary that we have discussed, and in reality, model is already trained on enough amount of data, so you do not need to actually worry about anything. But still, this is a code. If you just want to go deeper, if you are a machine learning engineer, if you just want to see the inner workings of it, you can do that for sure. Just go and explore. I don't want to do that, so I will simply say let's try to download the model first of all. So how you can just download the model? I will simply say pip install GenSim, okay. And just you can say quick intro. So what I will do, I will also provide all these notebooks that we are discussing right now. So I will simply hit this particular tab and it will take some time because it will download the model. And as you can see, 55 MB is about to download, successfully installed. So it is done. It is a small model. Okay. So now what we're going to do, we're going to use something called as downloader within GenSim. So we'll simply say from GenSim dot downloader import API. Import what? API. I think it is in small. Import API. So what this will do? This will load our model which has 300 dimensions. Remember that we talked about that thing? Everyone? Okay. So let's initiate our model. So we'll simply say model equals API.load and the model name. Now what is the model name? Obviously you do not need to remember it. There are so many documentation that you can read for the model, but I am just writing it for your case sake. Word-to-vec, okay, then Google. Okay, then there are some options available. There are so many different variants of this model, but I'm using this one. Okay, 300. There are so many. Import API gensim.downloader, what is the issue, bro? Oh, okay. So we just need to write import, not from. So simply say as API. Okay, so basically this is the abbreviation for this whole import that we have done. So now it will download this model, which is of almost 1.5 gigs, as you can see on your screen, 1662.8 MB. But you do not need to worry, because this will be downloaded on this particular VM and we are free. Do not be confused that, hey, will this model be downloaded on my Google Drive? No. This will be downloaded on your virtual machine that you're using, this one. So this will take some time. Okay, just allow it some time. Once it is downloaded, you just need to write only, and basically not even write. Once you initiate this model, that means you are good to use this model directly. Simple. I will just show you, just wait. It will just take some time, maybe just 2 to 3 minutes. Once it is downloaded, you can just use it to create your basically embeddings for each word, whatever you want to do. Make sense? Okay, good. So let's wait, and once it is done, I will just show you. So bro, our model is downloaded. Do you know what? Now I can literally write, if I, let's say, want to find the embedding for the word cat. Okay, let's try to find it. Model of cat. Okay, I want to just find the embedding for it. And I will create the variable for it. I will simply say cat vector. Let's see. It is done. Let's try to display it. Cat vector. See, wow. So this is the same vector, right? But this time, how many, quick question. How many items are there in this particular array? How many? 300. Remember, it has 300 dimensions. And how we can just verify that? I can simply show you cat vector dot shape. Okay. So I'll get 300 comma 0, because this is just a 1D array. So 300 dimensions. So each vector will have 300 dimensions. Okay, so this is the dimension. That means machine will understand this word called cat like this. Wow, literally wow. Should I just try my name? Let's see. Model of Ansh. Who is Ansh? Okay, who is Ansh to you? Let's try to run this. Ansh is not present. What does it mean? So when this particular word-to-vec model was trained, they didn't take me seriously. They didn't think like, hey, we need to just find the meaning of Ansh. Okay. Because when this model was trained, I think I was just 10 years old, I guess. Because it would be trained around 2010 or 11, right? So I was just 10 years old. So they didn't take me seriously at that time. No one took me seriously at that time. No. So, jokes apart, you can literally find the embeddings for each word, for the data, for the text, for the words which are trained. And how they train the model? Continuous bag of words, CBOW, and just tell me in the comment section. I just told you 2 times. Just tell me in the comment section right now. Right now. First is continuous bag of words, and second is, okay, I know you commented skip gram. Okay, good. So now let's say I want to find the embedding for dog. So this is the embedding for dog. See? And again, the size will be 300. We know that. Make sense? We know that. Okay. Let's say I want to find the most similar word with dog in the model. Okay, let's do it. How we can just do that? We can simply say model dot most similar. Okay, and I will simply write dog. So whatever word will be most similar will appear here. Let's see. I'm also testing it for the first time. Okay, so dog has the similar words with this array: dogs, puppy, pitbull, and whatever. Okay, so these are the words based on the descending order. So this is the most similar word. Okay, this is the next similar one, then this is the third similar one, and that's it. And how it is just finding the similarity, you know it using the cosine similarity, using the distance formula 1 minus cos theta, right? So it first of all plots the you can say your vectors, then it finds an angle between those, and then it finds a distance, and then you will get the answer, right? So this is the most similar one. Okay, so this is your word to vec under the hood. Word to vec. Don't worry, I will just provide this notebook as well in my GitHub repo, so do not need to worry. And quick question, Ansh Lamba, if you provide the GitHub notebook in GitHub repo, how we can just access it? So there are two options. You can simply copy the code for each cell. Let's say first of all for this, then for this, then for this, and blah blah. Second thing is you can download the notebook from the GitHub repo, okay, and then you can simply go to file and open notebook, and you can open my notebook and you can simply run the cells. But I would expect you to do some hard work, just even copy paste the code from my notebook. Okay, not a big deal, bro, just like 3 to 4 lines of code, that's it. So this is the way that you can just convert your words into the embeddings, semantic meaning. Ansh Lamba, I love word to vec. Is there any problem with this? Yeah. What what is the problem? What is the problem? There's no problem, we're gonna use it. Bro, let me just tell you the problem, okay, and then you will just talk about the solution. The problem is, let's say I pick a word called which is the good example, like the word okay, fan, like it is like a very common word that we just use. Okay, so what I will say, I will simply say I need a fan. Okay, I need a fan, or let's say please turn on the fan. Okay, let me just change it. So fan has 3 blades. Okay, fan has 3 blades. This is the first input. Second input is I am your fan. I am your fan of whatever. Okay, I am your fan. So just tell me one thing. If I use word to vec model, okay, to find the meaning or basically embedding for fan here, okay, and here, I will get the same meaning, right? In both the cases, because fan is the same word and it just gives us the embedding for each word that is on which it is trained on, right? Yes. So fan has the same embedding, but do you know what? Just have a look on the at the inputs. Are these two words similar? No. This is a fan, ceiling fan. This is a fan, like I'm your fan, right? So both the words are totally different. Word to vec cannot resolve this. Word to vec cannot resolve it. Okay. There's one more thing, because this is the one of the biggest thing. Second thing, let's say same input, fan has 3 blades. Okay, fan has 3 blades. Okay, let's talk about this in the solution part because you will understand better. So you know the problem, right? Because the same word has the same meaning, but their context is not same, bro. Context is different. Here the word fan has a different context. Here the fan, like in the second input, has different context. So how we can just take care of these things? Ansh Lamba, you are right. You are right. You are absolutely right. But Ansh Lamba, you said like we still use word to vec. Yes. In so many areas, to let's say train our small model to just find the meaning for just one single word. We do not need to worry about context. We still use word to vec in a lot of areas. Okay, so that's why I showed you the code, and that's why I didn't show you the code for bag of words. Okay, makes sense? Very good. So now, Ansh Lamba, what is the solution? What is the solution? The solution is actually attention. What do you mean? Bro, let's talk about it. So basically, there's a research paper called Attention is all you need. Attention is all you need. Okay, there's a very famous research paper. You do not need to read it right now because I will just walk you through each and every concept of it. Do not need to worry. But this is just a kind of heads up that we are just going to talk about that thing, because attention is all you need. You would have heard about this phrase because this is very common nowadays. Attention is all you need. So there's a research paper based on this, in which they introduced something called as transformers. Whoa, finally the word, and I would say everyone was waiting for transformers. So transformers solved this problem efficiently. What did I say? Efficiently. Okay. Before transformers, there was another concept called sequence to sequence model, which was purely based on RNN. But we do not need to talk about that. We just need to talk about transformers, because transformers are like enhanced version of sequence to sequence models, where they just process data in parallel. So we will directly jump onto the transformers. Okay, very good. But still I wanted to just tell you, okay, so sequence to sequence is like before transformer, but we do not need to worry about that, because we directly need to learn transformers. Okay, because transformers and sequence to sequence are very similar, but sequence to sequence are of no use right now. Transformers are of use. Okay, good. So now what did like transformers do? Like why like they changed everything, and why everyone is talking about transformers? And Ansh Lamba, now you have just mentioned about all the fundamentals. Now there are so many fancy keywords coming in our mind. What is LLM? Okay, now what is, you can say, vector store. Okay, now what is GPT? I know. Hold on. I'm here, bro. I'm here. I know all of these fancy words will be coming in your mind. Okay, and it is the best time to talk about these, because all are interlinked. All are interlinked. And now is the best time to talk about that. Why? Because now you have the fundamental ready. This is also a fundamental thing, by the way, but still you have that capability to understand the concept. You have that particular power to understand that. Make sense? Very good. Do not worry about any of these keywords right now, because you will understand each and every keyword easily. Okay, but yes, I know that you are worrying about these keywords, but I'm also giving you the heads up. I will take care of it. Okay, I will take care of it. Now let's try to talk about transformers. We will talk about transformers 2 times. One in brief, very brief, high level. Then we will go deeper. Okay, first high level, which will be taking care of these concepts called LLM and all those things. Okay, then we're gonna go deeper. Encoders, decoders, encoder only model, decoder only model, and all those things. Make sense? Make sense? Okay. GPT model, BERT model, T5 model, all those things. And what is that research paper? This is the right time to talk about all of those things. By the way, transformers would need a dedicated video. Basically, LLMs and transformers would need a dedicated video. And if you need that, just tell me in the comment section. I will just tell you the inner workings of transformers as well. But not everyone wants to know transformers inner workings. Okay, so we will not be going extreme deep in transformers, but we will be going in deep in transformers. Why? Because you need to understand the concept. You need to understand, whenever you just talk to chat GPT, how it is generating the text for you. It is not magic, it is pure logic. Okay, so you need to understand all those things, and we will just talk about that thing. Yes, for sure. But for statistics, how to measure Q, K, V, which is like query and then key and then values, do not worry about that. Okay, so that is like pure, little bit mathematics, little bit logic. But if you want transformers videos, LLM videos as well, like a dedicated video, obviously this boy is here to create that video as well. But for now, for this particular video, we will cover, yes, transformers in deep as well. So just a quick heads up, we will cover this in deep because this is the backbone. Okay, very good. Now let's see what are transformers. Okay, let's see. Are you ready to understand transformers? I am very excited. I am very excited to explain this whole concept. And do you know what? You're gonna love this. And don't worry at all, because I just written down all of these things because I wanted to just tell you like what's going on behind the scenes. And just the good news, we are not going to just focus on these things, because these are just for the design, like all these sine, alpha, pi, theta, all these equations. But yes, under the hood, when transformer model was just in its, you can say, building phase, obviously there were like so many critical statistical functions, mathematical theorems that were used, obviously. But yeah, this is just a kind of design. Okay, so are you ready to understand transformers? Do you know what? Do you know what? Let me just make it very, very clear. When I was learning about transformers, I referred to so many different sources, books, research papers, tutorials, some online blogs, so many things, because transformers were like not very easy to understand. Okay, so I also revisited those things at least 10 times. So I want a just small promise from your end. You need to rewatch this transformers section multiple times if you want to learn better, if you want to understand better. I do not want to please you to do that, because I'm not just doing it for the sake of views. Okay, let me make it very, very clear. I'm just asking you to do that so that you can understand and remember it. And the fun part, I'm not saying that you need to just watch it 10 times, because you can just trust this guy. You will understand almost each and everything. And I would say if you just watch this particular transformer section 2 to 3 times, it will be enough. And in some cases, I would say 2 times will be enough. But why 2 times? One time? Not one time, because even if you understand everything, you need to watch this part for one more time so that you will remember everything. Okay, but 2 times is a great deal. Let me be very honest with you, bro, because I visited these topics 10 times, more than 10 times, and I'm not lying. Okay, so I want just this small promise from you. Okay, and if you have made this promise, let's try to understand and master it, and I will just take care of everything, that you will remember everything. Even if, let's say, someone in your street, in your city, in your interview, wherever, they will ask you, hey, do you know how transformers work? Do you know how chat gpt works? Do you know how llms work? You will say, yes, we know that. So it will be that powerful. Okay, so let's talk about transformers in a nutshell. Okay, yes, we're gonna discuss this in detail as well and high level as well. It will be mixed, so just enjoy, sit back and enjoy and just binge watch it. Okay, just you will love it. Okay, so let's talk about transformers. Like, what are transformers? Very good news. Okay, because I know you are a kind of updated person, and you know that now we have some amazing technologies around our world. It is called chat gpt. Okay, we have gemini, we have claude, we have llama, we have so many things, right? So many things. You would be aware of these things, I'm so sure. Even if you are like very new to this AI world, you will be aware of chat gpt, I'm so sure, right? What is chat gpt? What if I tell you that all these models or all these technologies are built purely on transformers? That's it. That means the backbone of all the modern revolution is based on this concept called transformers. That's it. Ansh, Lamba, are you serious? Yes, I am serious. Everything revolves around transformers, nothing else. Literally nothing else. Wow. So that means you'll be just understanding how ChatGPT works. You will be understanding how LLMs work. We will be understanding how they are just doing all of these things. Yes. Okay. So, and obviously I love practicals. So let me just show you a amazing practical. What is that practical? So I have just brought my ChatGPT screen. Okay. You can use your own ChatGPT accounts if you want to. Okay. Because you can just use your account, right? Just to feel the vibe. So let's say I will ask, or basically I will make a request to this chat gpt. Okay, so I will say, hey bro, um you can say, you can literally ask anything, right? You can literally ask anything, and when you are just recording something, you will be like, what should I ask? Literally ask anything, bro. um do you know what do you know what i let's say, do you know who is Ansh Lamba? Let's say, okay, do you know who is Ansh Lamba? Let's ask. So he will say, hey, I'm not familiar with the Ansh, Lamba and widely non-context, blah, 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 whatever. Okay, so this was a kind of I would say, let me just refresh. Bro, what are you doing, man? I was like thinking, see, by the way, if you will ask ChatGPT, you will obviously get the answer, but obviously I have not logged in, so I'm not using the updated models. Okay, so just go and search, you will get the answer. Okay, such an humiliation, bro. I was expecting a good answer to flex. Okay, so let's say, um, I want to eat chocolate. Okay, I want to eat chocolate. That's it. Good choice. Chocolate is always a comforting idea. What kind are you craving? Something like rich and dark, creamy, whatever, blah, blah, blah. So this is the answer, right? So this is the answer that I have got. How? Literally how? I sent my input, I got this particular output. Do you know how? Let me just tell you. So let me just explain you here. So first of all, this is my input. What is my input? My input was this. I want to eat chocolate. Perfect. This was my input. Okay. Very good. Do you know what? You already know the initial steps of transformers. Just think about it. What will be the initial first step? If you said tokenization, well done. Well done. Well done. Good job. So the first step is tokenization. So what it will do? It will tokenize my input. Make sense? And we already know how it will do the tokenization, right? So it will simply create one token for this, one token for this, one token for this, one token for this, and one token for this, right? Or even forget about like tokens. Let's start from very scratch. Let's do it. It will take extra efforts, but you will understand everything. Okay, so this was my input. Okay, this was my input. So this input actually passed through this transformer. Okay, or you can say ChatGPT for now, because ultimately you will understand everything. So let's say ChatGPT. Okay, so this was my input. It passed through ChatGPT, and ChatGPT generated this particular output, right? Good choice and blah blah blah. Make sense? So this is the output that it generated. Make sense? Good choice and blah 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 blah. So it generated this. Okay, so this is a kind of magical box, this ChatGPT. And now I will replace this ChatGPT with something called as transformers, because this is using under the hood transformers. ChatGPT is just like a web application, right? Under the hood it is using transformer. What kind of transformer? We will talk about that. Okay, don't worry, but for now just transformer. So under the hood it is using a transformer which is doing this thing. Wow, but how? I know you are really curious to know. So now let's talk about it. So now we can just talk about the first step. The first step of our input will be tokenization, right? So what it will do? It will tokenize our input. Make sense? Okay, very good. So token 1 is this, token 2 is this, token 3 is this, token 4 is this, token 5 is this. Very good. Makes sense. Okay. So it will do the tokenization. Now a very good student who is like very ideal and very bright student, front bencher, not a back bencher like Ansh Lamba. Okay. Oh, by the way, I was a back bencher, but like I was the one who used to give all the answers from the back seat. I used to shout, "Hey, ma'am, this is the answer." So be that guy. So this is basically the input. Okay. So it will first of all perform the tokenization. Make sense? Make sense? Make sense? Everyone? Okay. Now a very good student, a bright student, front bencher student, whatever you want to say. Okay. The person will say how it will create the tokenization, how it will create the tokens. Because Ansh Lamba, you said that sometimes we pick the whole word as a token. Sometimes we break the word into multiple sub tokens. Okay. Because we discussed in the fundamentals, right? Okay. You are right. So that is the concept. That is the concept. So what happens, so let me just show you. So what will happen, so let's say this is our input, I want to eat chocolate, whatever. Okay, so now if I simply bring this screen here. Okay, so I've removed the input just for a second, just to show you. So let's say I want to know how it will create the tokens for me. Just a quick note, and you can just take notes for this. Because if someone asks you, hey, this is your input, just tell me the tokens for this, that person can play smart, and you need to be even more smart. You can simply say, bro, tokens are dependent on the models. What did I say? Tokens are dependent on the models. So let's say I have written, I want to eat chocolate. So tokens for this particular input will be different for, let's say, ChatGPT, will be different for, let's say, Copilot, Microsoft Copilot. It will be different for Gemini. Okay, so it will be different for different models. It will be different for, let's say, Claude. Oh, so it is not specific, or it is not a standard. No, it depends upon the vocabulary of that particular model we are using. Make sense? Because it depends upon how they have created the embeddings for it. So I can literally show you the live example. So let's say this is our input, right? So let me just open a website called Tick Tokenizer. You can also search it. And this is a very good website to just visualize our tokens. And let's try to use this one, Tick Tokenizer API. So what it will do, let me just first of all remove this system blah blah blah, because by default you will see this filled up. So you can just remove it. Or you can do one thing. First of all, before removing or doing anything, or I will just, okay, let's stick with it because I want to show you multiple examples. So first of all, pick your model. Okay, so there are multiple transformer models. Okay, if I pick, let's say, GPT-4. Okay, GPT-4. Let's say I want to pick this model, and my content is, just put your content in the user. Okay, because there are like multiple system messages and user messages. You do not need to worry about that, what is that thing, but simply put your content in the user content. Okay, so let's say I will say I want to eat chocolates. Okay, that's it. Do you know how many tokens did I create? 17. What? Yes, 17 tokens. The very first token is I am start. What is this? We didn't write anything like this. So these are the system default tokens, which will be always there for starting up the process. You can ignore this, but let's start with user, because we have just put our content in the user, right? So first token will be I am sep. Okay, this is also like default or special token, ignore it. Then first token is I, see, purple color, then want, then to, then eat, then chocolates, and then space. So these are the 1, 2, 3, 4, 5, 6 tokens created for my text, for my input. Make sense? So it actually created one token at a word, but it doesn't mean like it will always create one token on like per word. Okay, but yes, for this time it created that thing. Okay, and let me just take a complex example so that you can just see the difference, where it can just break the things into multiple tokens. Let's say I want to eat strawberries and I want to run 10 kilometers. I don't know. That's it. Let's say this is our context. Okay, so what it did, it has created token. First token is I. Okay, second is want, then to, then eat, then strawberries, then and I want to run 10. See, 10 kilometers is a single word here. There's no space, but according to the model, it created 2 to 3 different tokens. See, 10 is one token, K is another token, MS is another token. Oh, so it literally broke our one word into multiple tokens. Make sense? Make sense? So this is a token that I got from GPT-4 model, which is used by ChatGPT. Let's say I want to pick another model. Let's say this DaVinci. Okay, DaVinci, whatever you want to say. Okay, so here I can simply write the same thing. I want to eat strawberries and I want to run 10 kilometers. Okay, here, and I don't know. Makes sense. So here it has created these tokens. Let's say I want to eat strawberries and I want to run 10. Similarly, it has created these tokens like this, KMS, and then comma, and I do. So Dawn, Dawn has one token, and then apostrophe, and then T has a different token. So this has a different style other than like that GPT model. So this way you create, not you, like model creates tokens as per the model preferences and model's vocabulary. You have zero control over this. Make sense? So I wanted to show you like this as well, because I want you to understand everything with the labs and with everything. Okay. So now you know how it will create tokens. Very good. This is the first part to understand of like transformer, like very basic, but very helpful. Just use this website. It will be very good. And the other one that I personally recommend, if you just want to compare the different GPT models only, that means OpenAI models, and it is like OpenAI tokenizer. So if you just open this OpenAI tokenizer, it is a great platform. Here you can just compare multiple GPT models only. So let's say I copy the same text here. If I write the text here, you will see here the context without any special tokens, which is like a good way to display for some users. So it's your personal preferences. Okay. So this is the way that it does. Make sense? Okay. Now you will say text. So text is actually divided into these tokens. Now what is this token ID? What is this token ID? This is very important, and you would see the token ID here as well. See 40, and if I hover over 40, I will see I. If I hover over 765, so this is want. Ansh Lamba, can I make a guess? Make a guess. I know your guess will be 100% right. Can we say that this token is associated with this ID, and that's why we call it as a token ID? Exactly. So under the hood, obviously machine does not understand the words. So what it does, it creates the tokens, but it at the same time allocates a ID. It has zero meaning. Do not compare it with the embeddings. No, it is just an ID. It is just ID. Let's say you are studying in a classroom, right? So you have a name. Let's say called Rahul. Okay. So your roll number is, let's say, 35. Just that ID. That's it. Some random numbers. Okay. That's it. So that is why, see, want has the ID called 765. But a quick question, will the IDs be same in different models? Obviously not, because every token is different in different models. So IDs will also be different, right? Very good. So here you are seeing the IDs, token ID. So here we have 40 ID for I. Here we have 40. This is just a coincidence. Then we have want, then 765. And here we have 1682. Okay, see? 1682 for want for GPT-4, but for DaVinci, want stands for 765. Okay, so these are just the IDs. So under the hood, if you are familiar with some dictionaries, so you can treat it like a dictionary. Let's say key value pair. So key is, let's say, I, and this I has ID called 40, like this. Simple. Do not make it complicated. It is very simple. Okay, understood? So this is like tokenization. Okay, very good. Simple, no embedding, nothing, just tokenization. Very good. Okay, and just explore this website as well. This is also good. And if you see, we have 20 tokens and 69 characters. If I use GPT 3.5, I will get 21 tokens, one token extra. Why? Because it has obviously lesser vocabulary. It doesn't have like vocabulary for bigger words. That is why it has broken down one word into multiple ones. Okay, GPT-3, which was the older version, it created 20 tokens. Okay, so makes sense. Okay, so just explore these websites, just play around it, and you will feel connected. So this was the very first step. So what it does under the hood, now you understood that tokenization. Now I can just talk about that thing. So let's say I wrote, I want to eat chocolates. Chocolates. It's not chocolates. So what it will do, it will simply create the token. So let's say one token for this, one token for this, one token for this, one token for this, one token for this. Very good. Okay, this will go to transformer. Now you know. Okay, transformer, or let's say TRFRMR. Okay, transformer. Okay, makes sense. So this will go to transformer. Now, do you know what will happen? You will say, I know what will happen. What will happen? You will say, bro, it will generate this text. Ha ha ha. No. What? Bro, we are not blind. We can see this. See, it has generated this. Listen to me. It will not generate this. So what it will generate? It will generate only and only one token. What do you mean? So it will simply generate good. What? Yes. It will only generate good. Oh, okay. And this is one iteration, first iteration. Then do you know what will happen? All this input, I want to eat chocolates, okay? Along with this good, let me just write it here. Along with good. This is the second iteration, okay? Now when we have good, so I can remove good from here and this will be here. Okay, good. Okay, and here obviously it will have good. So now what will happen? This input will have one new member. It's called good. You didn't pass this. You didn't pass this. Your transformer created this good and added it to your input. Now this input will go to this transformer again and it will generate something called as choice. Wow. Now good choice. Okay, make sense? Then this choice will also be appended here. Oh, and then it will go here again and it will create something called as hyphen. Okay. Then it will go back here hyphen. Then this will create something called as chocolate. So what is happening here? Transformer will generate token one by one. Your chat GPT is generating token one by one. And on the basis of that one token, it generates another token. This is not the text that is just like generated in one go. No, never. So it only generates one token at a time. That's it. That's it. Make sense? Make sense? So now, whenever you will be just working with ChatGPT, you will feel okay. Why we get response like one by one? If you just closely observe at the speed, you will see that text floating one by one. It is not just a lag. It is generating token one by one. Okay. Once all the tokens are generated, then it will just end the process and you will see the final output. The speed is so high that you cannot even realize that it is generating token one by one. That is the power of transformers. It works parallelly. It has like so many parallel computation. It has multi-head attention as well working in parallel. We will be just talking about those as well. So do not worry at all. This is the very high level overview of transformers. Okay. Okay. Ansh Lamba, a quick question. So we know that we were just talking about embeddings as well, right? Yes. So Ansh Lamba, you said when transformers and like creates the content or generates anything, it creates something called as contextual embeddings. Like it has the meaning, contextual meaning. We saw the example. Okay, which example? Where we just discussed about fan, right? Fan. So how it generates contextual embeddings? How? So there are some things. It's called self-attention mechanism. Okay, it has something called as bidirectional or unidirectional masking, all those things. So these are the inner workings of transformers. How it creates that? Because do you know what? When it will be creating this good word, it is not like you can ask me this question: how this good is created? We know that good is created. Now, how only good is created? Why is like nothing like no other word is created? Why? You will get the answer why. because it has some mechanism that it follows. Okay, but this is the high level overview that you need to understand. But now you understand this, so now you have the quite good understanding, not technical but conceptual knowledge. Okay, that how it creates all of these things and everything. And now you have the knowledge about tokenization as well, like how it creates the tokens, right? Very good. Very, very, very good. I hope you were able to understand this concept. Very good. Because this is the basis of everything. Okay. Now we need to talk about transformers in detail, obviously. But before that, we need to talk about some types of embeddings. Types of embeddings? What do you mean by types of embeddings? Because there are different types of embeddings. Really? Yes. There's not like only one type of embedding. It's called like multiple types of embeddings. Make sense? And I will just show you the code and all everything. Don't worry at all. Under the hood, you now know what is the high level concept. You have got the vibe how ChatGPT is working. Okay, not completely. It is just 1% of it. But do you know what? The other 99% of that is dependent on this thing. Make sense? Okay, very good. Now, just to give you a quick brief. Okay, this transformer has two major parts. Two major parts. The one part is called, if you already know, just let me know in the comment section. The one part is encoder. The other part is decoder. What is encoder? What is decoder? We will talk about that. And you know what? The fun part. It is not mandatory that it will have both the parts. Ansh, Lamba. Now things are going complex. Don't worry. This is just like a kind of, I'm just trying to generate that interest, that curiosity in you. And I made a promise to you that you will understand everything. That means you will understand, okay? Don't worry at all. It is just a high level overview that you can just write in your notes that transformer is a magical box. Okay, magical box. And within that box, it has two major parts, encoder and decoder. That's it. That's it. Just write this thing and you are done. Okay. Now we need to just keep transformers aside and we want to understand types of embeddings, because you need to know types of embeddings to understand the further things in transformers. Okay. Let's now try to see the types of embeddings. Okay. Let's see. Now let's talk about the embeddings types. Now, what are embedding types? You already know the answer. We are just covering it up. Really? Yes. So remember in the word to vec embeddings, we were just able to find the embeddings, but they were static embeddings. So the first type of embedding is static embedding. Static embedding. What are static embedding? And you will also know the reason like why I said like word to vec are still like relevant, because we use static embedding in transformers as well. Yes, as the first step. Not using word to vec, obviously using our own GPT models which are based on much more dimensions, but those are also static embeddings. Okay, so first type is static embedding. What do we mean by this? Static embedding means, remember the example of cat in our like initial minutes of the video when we discussed it. Cat, when we were just able to find the embedding for cat. Okay, so we got the vector like this, like let's say 0.8, 0.1 and blah blah blah, 300 dimensions. Okay, 300 dimensions, because dimension size is just 300 for word to vec. Okay, very good. So this is called static embedding. Okay, now this is static. If I'm using cat anywhere in the sentence, in the paragraph, wherever, in the beginning, at the end, we do not worry. We do not care, because the embedding will be same. That is called static embedding. The other thing is contextual embedding, that we are just trying to focus right now. Contextual embedding. Now cat will get different embedding every time according to the sentence, according to the input. Okay, so for example, there is a sentence called I love cat. Okay, so here the embedding for cat will look like this. Let's say this is the vector for, let's say 0.8, 0.7. Okay, and I have a sentence called, let's say, I love, not I love, dogs hate cats, or let's say cat. Okay. Okay. Here the embeddings for cat will be different. Really? Yes. Because obviously cat is same in both the sentences, but cat's context is not same in both the sentences. Here the tone is like little bit polite, like related to animal love. Here, not really, right? So context will be changed. Context will be changed. Or let's take a very good example, because I don't have like much good examples for cat. Okay. So let's say, let's take the example of dog and cat. Okay. Or let's say, yeah, let's take example of dog and cat. Let's say dog dog hates cats. Okay. Or let's say dogs love cats. Okay. Dogs loves cats. Okay, makes sense. Here the embedding of cats will be different. Why? Because dogs love cats. It is not saying that cats also love dogs. Make sense? Like you know this, right? Because you are a human being, you can interpret this. Okay. Same way, like you like love someone and someone doesn't love you. Same thing. Okay. Okay, very good. So now I say cats love dogs. Cats love dogs. Here same thing. The embedding for this will be a little bit different. Why? Because I'm saying cats love dogs. I'm not saying dogs love cats, right? So embedding will be different. Okay. Ansh, Lamba. Okay. Ask this question. I know your question. Is it just about context? Like how it calculates the context? Yes. It's all about context. It's all about attention. It's all about attention. Attention is all you need. That where it needs to put attention. Where, on which part of the sentence. Makes sense. Makes sense? Okay, very good. So now there's one more thing. If you missed it, if you didn't observe it so far, it's not just about, you can say, context, or you can say it's about context, but there's a very strong factor which influences the context. Just guess it right now. I'm just giving you 3 seconds. Okay, because you can use the same example and time is up. So the answer is position. Okay, why? Let me show you. If I write cats love dogs, same words. Okay. So contextual embedding will not be very different, because dogs are obviously dogs. Okay. Cats will be like cats. Okay. Cats love dogs, same thing, right? So if I will just comparing the embedding for individual word, or basically individual token, it will not be very different. Like they will be saying like a little bit change according to the tone, but it will not be like very different. But you know what? If I will be finding the embedding for the entire sentence, it will be totally different. Totally different. Just have a look at the sentences. Dogs love cats is totally different from this particular sentence. Cats love dogs. Because this is saying that dogs love cats. That's it. It is not saying anything about cats. And this is saying cats love dogs. It is not saying anything about dogs. That do they love or not. Right? So both these sentences are totally different if we will be just finding the embeddings for the entire sentence. Make sense? So Ansh, Lamba, when we will be deciding to find the embedding for single word, and when we will be deciding to find the embedding for the whole sentence? So use your common sense. Obviously, we will start with finding the embedding for each token, for each word like this, and eventually we will aggregate all the, you can say, or you can say you will just find the aggregated weightage, or you can say aggregated weights, or you can say, just to keep it simple, you can say average. Okay, just let's say average of all the embeddings of each token, because at the end you need to find the context of the whole sentence after finding the context of each word, right? Common sense, but still I just wanted to highlight this. Okay, but our goal is not just to find the high, like end level embeddings. Currently we're focusing on just the single tokens, but still I wanted to highlight this so that you will not be feeling lost. Okay, make sense? Okay, so now we need to find the embedding, contextual embedding for our token, for our token. Now this is the goal, and this is the thing that transformers do it for us. Really? Yes. Yes, and there's a step-by-step process for it. Now you know the differences. Now you'll be able to understand that, because concept is very, very important. Make sense? Are you ready to understand that? Okay, it's not a big deal, by the way, but yes, it is a critical one. Okay, so let's see. So the first step, as we know, in the transformer process is tokenization. Okay, but why I have written tokenizer? Because within the transformer, this is a complete process. It's not just about tokenization, it's also about generating the embeddings as well. So let me just tell you how things work step by step. So let's say, let's take the same example so that you will just understand better. So let's say we just pass the input called at I want to eat chocolates. Okay, I want to eat chocolates. So what it will do, this tokenizer is the complete process. Okay, let me repeat, complete process. So in this complete process, step number one is creating the tokens. Okay, creating the tokens. So this is one token, this is one token, this is one token. Make sense? The second step is assigning the ID, token ID, right? Because token or token ID, same thing, but we just assign a number, right? So we'll simply assign, let's say, any number. It can be literally anything. So you can just take the hypothetical situation as well, and you can just take the, you can say, accurate numbers as well. Choice is yours, but you do not need to take the actual numbers. You can just simply take the hypothetical situation, but I am just giving the flexibility. Okay, so let me just write the random IDs. Okay, so let's say this ID is 40, this ID is, let's say, 1100, 1200, whatever. Okay, some random IDs, 45, 765 and 768. Okay, makes sense, some random IDs. So this is what is this called? Token IDs, as you all know. Okay, token IDs, step number one. Okay, now once we have assigned these token IDs, then what we will do, we will simply fetch the static embeddings. You already know about this, right? Static embeddings, very good. But there's like one fun part. Instead of like this, let's say static embeddings, so you have so far just created static embeddings of 300 dimensions, just 300 dimensions, right? So let's say let's say for cat it was like 0.8, okay, and then 0.1 and blah 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 something. So it was like just 300 you can say dimensions, right? But do you know what, with the advancement of the models, now we have much more dimensions, and I would say now we have approximately 1536 dimensions. Yes, with OpenAI models, let's say GPT models, whatever models. So they have 1536 for the smaller version and 3000 something for bigger models. So let's say we will be just having the embeddings, okay? Static embeddings, not contextual, just static embeddings that you know how to find it. And static embedding, we already know the meaning will not be there. It is just like the static meaning. So I will be same for everything, want will be same for everything, and to will be same for everything. Okay, so this is like static embedding. Okay, so let me just create that vector for you. So let's say this is the, wow, nice drawing. So let's say this is the vector for you. Okay, and here you have, let's say, 0.4, 8, whatever. Okay, some numbers, blah blah blah, and dot dot dot, and there are total 1500. Make sense? 1500 vectors. Make sense? So now you can just draw it on your own in your notebook as well. So these static embeddings will look like this. Okay, so I have just drawn for you so that you can just draw it on your own as well. Not a big deal, just like number representation, static embeddings. And this time you know the size of this 1536. You do not need to remember the size because it will be keep on increasing obviously in the future as well. So just remember, like, we are just now creating more and more dimensions. Make sense? Okay, very good. Now our tokens are created, token IDs are generated, static embeddings are generated. There's one more thing. Remember, like, we talked about the position of the text. Like, cats love dogs, dogs love cats. Both are different, even if their tokens are exactly the same. How? Because their positions are different. So we need to note down the position of each token as well. And this is called position encoding. What is it called? Position encoding. So we'll simply provide the number, let's say 0, okay, then 1. This is basically the position, 2, 3 and 4. That's it. Just the position, like where it is just appearing in the sentence. That's it. That I is appearing at the front, at the basically this is the starting point. Then we have want at the second position, so it will just capture this as well. This is called position encoding, and let me just write it for you. So first of all, tokens, then token IDs, okay, then static embedding, okay, then position encoding. Make sense? Position encoding. So all these 4 steps, when combined, it becomes the tokenizer part of the transformer. Make sense? Simple? Yes. It was simple, but yeah, it was required. It required some explanation. Make sense? So this is the tokenizer part. Tokenizer. Okay. Now, what happens after tokenizer? Let me just show you. So bro, are you ready to understand transformer? Let's go inside the transformer and let's see like what actually happens under the hood. Okay, so this whole blue box is a transformer, this one. Okay, within this transformer we have these 3 major areas. One is tokenizer, second is block stack. I also call it as transformer block stack, but in common language you can call it as like block stack. Then we have LM head. Okay, perfect. I have already explained you the tokenizer step. So let's say this is your input. Tokenizer, what it will do? It will create the embeddings, static embeddings plus positional encoding as well, right? Very good. So let's say this part is done and you have understood this part. Then what will happen? Then all these static embeddings will go to the block stack, or basically transformer block stack. These are multiple transformer blocks which are placed one on top of other, and that is why it is like called as stack. But just for the simplicity, let's say we just have one block, okay? Because the same thing will be done by like multiple things. Make sense? Make sense? Make sense? Make sense? Very good. So now let's say we just have one block, okay? We just have one block. Make sense? Okay. So if we have one block, okay? So what happens within this one block? It will convert your static embedding into the contextual embedding. So remember our example, this example, I want to eat chocolate. So earlier we just found the embedding for I, then want to, then to, then eat, then chocolate. So now it will convert the embedding for, let's say, chocolate with context. Now chocolate is not just a chocolate. Chocolate has the context of me as well, of I want to eat as well. It is not just a kind of standalone embedding. Now this chocolate has context of this previous tokens as well. Oh, this is the magic of transformer block. This is the magic of transformer block. Okay, makes sense. So now we are saying that chocolate has the context of the previous tokens as well. Yes, that's it. Okay, very good. Very, very, very good. Okay, makes sense. Now, this chocolate has the context. Similarly, other tokens as well. Like each static embedding has the context of the whole statement, like what we are trying to say. How it is achieved? It is achieved by a concept called self-attention. Just take notes because we're gonna discuss so many concepts here. Okay, self-attention. What's so special in this self-attention and how it creates the context? How it creates the context? Okay, very good question. So what self-attention will do? Let me just write the text here. So let's say this is a text. I want to eat chocolates. Okay. So first of all, this token will be picked and it will be referred with or basically compared with all the other tokens. Okay, all the other tokens, and it will just try to find the meaning, similarity between these things, and it will get the contextual embedding, contextual meaning of this I. Same thing with want. Want will be compared with all the other tokens, all the other tokens. This I, then two, then eat, then chocolate. And similarly at the end, let's say this chocolate. Make sense? So this will have the context of each particular token. Each token. Wow. Literally wow. Make sense? Very good. Now there are two types of self-attention. Just pay attention here. Okay. There are two types of self-attention. One is masked self-attention. Okay. And second is bidirectional or basically normal self-attention. What is the difference between these two? In the masked self-attention, you basically model is only allowed to refer to the previous tokens only. It will not look at the future tokens. What did I say? So for example, chocolate, it will only attend the previous tokens. Okay, and chocolate is the last token, so that it will attend the all the tokens. So let's take an example for this one. Eat will only attend these three tokens only. It will not attend I, like it will attend I want to, that's it. It will not attend chocolate. Why? This is called masked self-attention, where we simply put a mask on the future tokens. And whenever we just talking about chat GPT, okay, whenever we just talking about any these models that we are using nowadays, all are based on the masked self-attention. Yes. Okay, you will say then why do we have self-attention and where do we use self-attention? Self-attention is also used but in very rare cases, and you will get some more clarity when we will be just talking about encoder only models, decoder only models, encoder decoder both. But for now you just need to understand that masked self-attention means the token can only and only attend the previous tokens. That's it. And in ChatGPT, in all these models, we simply used masked self-attention. That's all you need to know for now. Okay. Very good. And obviously we're just taking an example of ChatGPT like here. So obviously we're just talking about masked self-attention. So whatever I will get with this particular, you can say transformer block, let's say I want to eat chocolate, every embedding will be contextual embedding, but only with the previous tokens, and that is enough. That is enough. And you will know the reason why it is enough. Okay. So transformer block will use what? Self-attention. And what kind of self-attention? Masked self-attention. Okay, got it? Very good. Masked self-attention. So it will simply provide you these embeddings, contextual embeddings, full of context of the whole sentence. Very good. Now these contextual embeddings will further go to LM head, and now let's see this part. So what will happen in this particular part? In this part, each contextual embedding, see, these are contextual embeddings, right? But not every contextual embedding will go to the third part, which is called LM head. Only and only the last token, the last token will go to LM head. Why? And you know the answer. Why? Because this last token has the context of all the previous tokens. Oh, okay. Let me just explain this point with an example. Same example. I said I want to eat chocolate. You provided this whole input, yes, but not all the tokens will go to predict this particular word good. No. Only chocolate, the last token, will be used to predict this thing. Only and only last token. That's it. Because this last token has the context of all the previous tokens. Make sense? Make sense? Good. So even if you write, let's say, a full paragraph of 100 words, full paragraph, big paragraph, yes, only and only last token will be used to predict your next word. How powerful is your last token? And now you can just imagine, because last token has the context of all the previous tokens. Make sense? Good. Okay, so far so good. So what will happen? This particular embedding, last tokens embedding, which is chocolate in our case, will go to LM head. Now what is this LM head? In short, LM head will use this last token and will show the probabilities of all the words from its vocabulary. So let's say it will show the probability distribution like this. It will say, bro, I have so many tokens and these are the top tokens that I think you can use. It will say the best probability is like for this word good, then second highest is O, then third highest is hey, then fourth highest high. So it picked this particular token because it has the highest probability. So good actually was picked, and you can see the result here as well. Good was here. Once it has just predicted good, what will happen? What will happen after that? You know that. It will simply add good in the input. Okay? In the input. Now same thing. This static embedding, okay, will be converted into, you can say, contextual embedding. And all the context, like all the context of previous tokens, will be stored only in this particular token. So good will be used to predict the next token, and next token has these options: choice, boy, bro, bad, all these things. So it picked only this one because it has the highest probability. What will happen? Choice will be here and so on. This is your transformer under the hood, how it is predicting the word one by one. Now a very good example I want to take right now, because it is the right time to take. For example, you will say, Ansh, Lamba, can we say that every time our transformer will pick, or basically LM head will pick, because obviously LM head is also the part of transformer. So in short, transformer will pick the token with highest probability? What do you think? You will say yes. The answer is no. What? Yes. It totally depends upon the temperature. Oh yeah, it's really cold here. Not that temperature, bro. Temperature of your model. Temperature of your model that you have picked. I am so sure that you would have heard about this temperature term if you are in the AI domain. If not, let me just tell you. So whenever we just use any LLM, okay, any model, any, you can say, transformer, we simply set the temperature while making the API calls, because right now everyone is making the API calls with temperature equals to 0. No one actually knows like what's the meaning of it. So when we say temperature equals to 0, we are saying, bro, you do not need to be creative. Just pick the token with the highest probability and that's it. If I say temperature closer to 1, closer to 1, let's say 0.9, 0.8, let's say 0.9. Do you know what it will do? It can pick this word as well, bro. Then at that time, it will be very, very creative. That's why if you make API calls to any LLM, you get creative answers if you set temperature to high instead of 0. 0 means you do not need to be creative. Higher temperature means you can be creative and you can pick some tokens with lower probabilities as well. Simple sorted. Simple sorted. Okay. So answer is no. Not every time it will just pick this particular token. It depends what temperature you have provided. Okay. Make sense? Very good. Very, very, very good. So this is your end-to-end working of the transformer. End-to-end working of the transformer. And as I just mentioned, that transformer has two parts, encoder and decoder. Encoder and decoder. Makes sense. And what we have discussed, quick quiz time. I haven't talked about this, but I just want to know, like maybe some people would know about this. What model we have discussed so far? Like in transformer, we have encoder, decoder both, right? So what do you think? So let me just tell you. Let me just bring the research paper now. Okay, now you are ready to read that. So let me just bring that transformers, or let me just search. I think it should be here. Transformers research paper. Okay, so let's see. So this is a very cool paper and it actually did the revolution. Okay, so where is that? I think view PDF. Perfect. So this is the research paper. And don't worry, we are not going to read this, but I just want to show you something. So this is the architecture of transformer. Just for a second, just focus here. Just do not need to worry about like what's written here. Just try to focus here. So do you know what? This is a complete transformer. Okay, having two things, encoder and decoder. This small part is encoder. This bigger part is decoder. Small part is encoder, bigger part is decoder. And when we combine both the things, it becomes transformer. This is the very first idea of transformer. When transformers were introduced. Make sense? So far so good? Very good. Now what happened with the time? We didn't want to use both the parts of transformers. No, we didn't want to use both the parts. Why? Because it is not actually very, very reliable if we just use both the parts. Oh, really? Yes. So we use ChatGPT currently. And do you know what exactly transformer model it uses for ChatGPT or any GPT model? It uses only and only this part, decoder, only this part, only and only this part. Oh, and this is your encoder part. Oh, okay. So ChatGPT uses only and only decoder part. And if you just try to read like what's going on here, you will understand it. Let me just walk you through. Forget about this thing for now. Forget about this thing, encoder only. Okay. Do not worry about that thing because we have just discussed decoder only. Okay. Because you need to understand transformers from decoder only perspective first. If you will just try to understand transformers from both perspectives, you will be confused, totally confused. I'm so sure. I'm 110% sure. I'm just telling you with my experience. That is why I just showed you the decoder only concept first of all. And let me just give you a quick walkthrough. So let's say this is your starting point, right? This is your starting point. This is output embedding, but here you need to write input. Why? Because obviously we know that our input will become output and that output then again will become input. Why? Because it uses the token and it appends the token in the input. Remember, like first it will take our input, it will predict the token, and then it will simply add that output in the input. So that is why it is written output, but just for the simplicity, you can write input. Okay, this is our input. We know that after once we have input, what we do, we simply convert that input into static embeddings, right? Very good. Then we perform positional encoding, right? Remember defining the positions of each token. Very good. Then what we do, we enter into the transformer block, right? So this is a transformer block, this gray area. And what is happening here? What is happening here? We are applying masked multi-head attention. You can just ignore this word multi-head. You can simply say masked attention or masked self-attention. Make sense? Once it is done, this you can just ignore because this is coming from the encoder part. So we have just discussed the decoder part. You can just ignore this as well. Then we perform some kind of feed forward thing. It is also called FFN, feed forward network. What is this thing? This is a kind of deep learning concept where you just enhance your embeddings. And just for simplicity, you can simply assume that this is a kind of optimization that we have just performed after the masked self-attention. After the contextual embeddings, we have just enriched it. Make sense? Then it will go to linear and softmax. What is this linear and softmax? This is your LM head, which will just output the probability. See, this is called LM head. So this is your complete working of decoder. And we just use decoder only in your GPT models, in your chat GPT, in Claude, in all the chatbots which are generating text or generating anything. Everyone is using this decoder only. Now Ansh, Lamba, we understood this. And thank you so much for that. Okay, by the way, if you just want to say thank you, you can just say thank you in the comment section. But why do we have then encoder only? Why? Let me just answer this question. Remember, I just told you that we have two kinds of self-attention. Yes. You mentioned that. I told you that for masked self-attention, we do not attend the future tokens, right? Like the tokens which are like already after that token. But do you know what? In encoder only, it attends both the tokens, previous and future both. How? So let's say this was our input. I want to eat chocolate. So do you know what will happen? Let's take an example of middle token. Let's say eat. So according to masked self-attention, it will only attend these tokens like to, then want, then I, right? But you know what? With an encoder only, it will attend this token as well. What is the benefit of it? You tell me. What is the benefit? Common sense. It is a common sense IQ question. What is the benefit of it? The benefit is simple. It will get more context because it can attend the future tokens as well. So whenever we want to apply or basically create a solution where we want richer context, we use encoder only model. A very good example that we will just talking about very soon about RAG. Okay, do not worry about RAG for now, but we will just talk about RAG as well. So in RAG, okay, or just forget about RAG. You will say like, Ansh, Lamba, what is RAG? So let's say I want to, like, I have a big document. I have, let's say, 100 pages of PDF, one PDF of 100 pages, and I want to store that PDF, or I want to just create the embeddings for it. Okay, so obviously if I want richer context, I would like to use encoder only because it will attend all the future tokens as well. So there I use encoder only model. Okay, decoder only for text generation, where you need to generate the text, where your focus is to generate something, it is decoder only. Where your focus is richer context, it is encoder only. Okay, good examples I have already provided. Let me just write it for you. Decoder only examples are GPT models, any GPT, let's say GPT-4, GPT-3, okay, Claude, Gemini, anything. Okay, now what is the example for encoder only? It is BERT. BERT, yes, it is called bidirectional encoder, or yeah, encoder something from transformers. It is like the full form, bidirectional representations from transformers. Let me just check the full form, but yeah, this is the full form. Okay, but bidirectional, I cannot search right now, but yeah, I will just show you. Bidirectional encoder representation from transformers. It is like this, I'm 90% sure. So with the explanation is in the name itself. Bidirectional means it will try to find the embeddings It will try to find the context using both the directions, bidirections, left and right both. Bidirectional and then encoder representation. That means only encoder part. From transformers, that means from transformer. So with the course of time, we modified the architectures of transformers as well. Now we call them as decoder only transformer. Okay. Decoder only transformer. And this is encoder only transformer. Okay. Ansh, Lamba, whatever you said is actually right. But a quick question. So, don't we use any model which uses both? Let's say we want richer context and we want to generate text as well. Yes. There we have like some very rare use cases, like we do not use very often, but yeah, there are some models. It's called T5 model. It uses both encoder and decoder both, but it will be very, very rare because you just need to put more focus in one area. Either you can just create the richer context or you can just generate the text, right? So this is your transformers under the hood, and I hope now you are able to understand what's going on. That is why, see, in the encoder only, you do not have anything called linear and softmax, which generates the probabilities, which predicts the next token. No, it will simply generate the embeddings and that's it. That's it. Contextual embedding and that's it. Okay, that's it. And if we are using encoder decoder both, I'm just talking about T5. So what it will do, obviously decoder only will do its part, but along with that, it will use the richer context from the encoder as well. That's why you are seeing one arrow here, but it is a very rare scenario. But this was the actual idea of the transformers. Make sense? Just take a snapshot of this and you can just save it. Okay, and let's confirm the BERT full form. Bidirectional encoder representative from transformers. Boom, 100% correct. See? So now I hope you understand the concept of transformers, like how we are just doing all of those things and like how it is predicting the next word, why we are seeing some crazy words sometimes, why we do just see like very formal language. It all depends upon how you are configuring your model. Make sense? Make sense? Make sense? Okay. I hope it was a good section about transformers. Okay. Very, very, very good. And by the way, like transformers, and now we just need to talk about a little bit about LLM. LLM, large language model. Everyone talks about LLM, LLM, LLM. Basically, LLM are language models. That means which can just work with NLP, which can just predict text. It is actually based on transformers. Okay. Transformers is like more technical word. LLM is like more commonly used word for transformers. Under the hood. Okay. I'm just talking about high level thing. Obviously, technically there'll be some similarities and there'll be some differences as well. But in a nutshell, you can say LLM means transformers. Really? Yes. Yes, yes, yes. LLM can be decoder only. LLM can be encoder only, but most of the LLM are decoder only. But yeah, there will be some rare scenarios where you will see encoder only LLMs. Let's try to find like if there are any encoder only LLM names. Encoder only models. I think they will just simply explain you the architecture, but yeah, there are some, I'm just telling you, it's very rare, but yeah, you will find some LLMs which are encoder only, but most of the LLMs are decoder only. Most of the LLMs. And today in the AI era, we are using more of decoder only LLMs. Okay. Makes sense? And obviously we use encoder only, but just for the contextual embeddings, just for the richer embeddings. That's it. We can create embeddings using decoder only, and we do using ChatGPT, as you can see. But when we need to just have more context, richer context, we can use encoder only. And what is the reason behind richer context? Again, quick revision. It's called self-attention. Right? Self-attention. It uses bidirectional self-attention, whereas decoder only uses only masked self-attention. Makes sense? Very, very, very good. So this was all about your transformers. Now let's see some of the more things, because now we know like how this chat GPT is generating text. Let's say now we know like how it is generating text, but everything we do with decoder only. Do you know what is the X factor of your response, of your result, everything? The X factor is this thing that you are passing it here. What is this called? It is called prompt. Why prompt engineering is so popular nowadays? Because this is the backbone of LLMs right now, and obviously LLMs are everywhere. So you need to understand some, first of all, the prompt. What is prompt? And do you know what? There are so many types of prompts. You will say, yeah, I know. If I say I want to eat chocolate, this is one type of prompt. If I say, hey bro, can you suggest me good chocolate, this will be a second type of prompt. Bro, what are you saying, man? No. Prompt has so many types. Zero shot prompting, there is like few shot prompting, there's single shot prompting, there's a chain of thought. These are so many popular prompt techniques, and I know you would not be using prompt techniques. Why? Because you do not even know what are prompt techniques. You are not even aware of those things. Do you know how to apply chain of thought? Do you know how to what are react prompts? What are those techniques? Why those domains are in demand? Do you know what? When prompt engineering domain was like started booming in the beginning, people used to think, ha, they are hiring someone who just write prompts. No, they were hiring people who can just apply those strategies and techniques to improve the prompting strategy. Because in order to get the feasible results from the LLM, you need to be you need to pass like very strong prompts, bro. Make sense? Make sense? Make sense? I hope it makes sense. So now, next we need to cover prompts in detail, and we need to see what are all the types of prompts available. Then we will quickly have a look at the RAG as well, because I know being a data engineer, RAG is everything. For those who are not aware of RAG, do not worry. Just a quick brief. RAG is a kind of end-to-end process we use to store and retrieve our data in the AI world. Okay, so it is something related to data, and being a data engineer, being a data professional, we need to master RAG. Okay, so we'll be having a deep discussion over RAG as well. Do not need to worry about anything. So you will learn RAG as well. Okay, make sense? Now I hope that all those jargons are completed, including LLMs, transformers, BERT, okay, encoder only, decoder only. Hey, by the way, one thing is left. What is that thing? GPT. What is GPT? What is GPT? What is GPT? Tell me. Let's discuss this. What is GPT? If I will just tell you the full form of this, now you are knowledgeable enough to tell me the answer. Okay, the full form of GPT is generative pre-trained transformer. Generative pre-trained transformer. Now you will just guess it. The answer is GPT is the decoder only transformer. Generative pre-trained, not trainer, trained. Pre-trained transformer. Make sense? Now you know what is GPT. GPT is just like the transformer where we simply apply decoder only architecture. And all these GPT models, let's say Chat GPT, Claude, all are GPT models. That's it. All are GPT models. Generative pre-trained transformer. Why generative? Because it generates the text. Pre-trained because it is already trained on the data. Transformer because it follows the transformer architecture. Simple. Make sense? Generative means because it generates the text. Very good. I hope you learned a lot of things, and your simple thank you will mean a lot to me. So why are you hesitant to drop a thank you? Okay, so now let's talk about the prompts in detail. Okay, let's see. So what's up, my data fam? Another day, another session on AI. Yeah, I know you're just watching this video in one go, but it's another day here, and I'm so excited to talk about I'm so excited to talk about prompts. We already touched this topic like very, very, very little. Like why prompts are so important, why prompt engineering is so much in demand, and why it is in demand. Okay. First question, what is a prompt? You know the answer a little bit because you can say whatever you are just giving to the LM. Okay. Now you can understand LM, right? Chat GPT, whatever, you now understand all the things. So whatever you are giving to that particular, who is calling me? Oh, okay. Ignore. Ignore. Ansh Lamba doesn't pick the calls. It's a delivery guy, Ansh Lamba. Pick it. Okay, we'll see later. So, what is a prompt, by the way? Prompt is something that we give, or we pass, or we ask the LLM to do something. Makes sense? Anything. Remember our input, I want to eat chocolates or chocolate. So that is a kind of prompt, right? That is a kind of prompt. So that means, in short, whatever you are just providing to LLM as an input is a kind of prompt under the hood. So we have categorized it as a prompt. Who is this? Okay. So I didn't pick the call. So guy just dropped all the things at the front door, and someone can take it. No worries. And okay, just do whatever you want. Okay. So now let's say I just provide the prompt. Okay. So from now onwards, we will not call it as input. We will call it as a prompt. Why? It is a technical term for input when we use it with LLM or AI. Okay. Second, there is a meaning behind it. Now just try to read what I have written. Prompt is the input text or instructions or questions or anything. Okay. Given to the language model, or basically LLM, large language model, to guide its output. Because obviously, whatever we are just saying, we are expecting some output, right? So we are guiding it what we want. Prompts can be questions, statements, tasks, anything. They are the main way users communicate to the model. Make sense? Prompt can range from simple queries, literally, what is the capital of France, to complex instructions like summarize the following article and blah 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 blah, whatever you want to do, right? This is the category of prompts in a nutshell. Okay. So let's say I just use chat GPT. Okay. So now let's say I will ask, what is, let's take the same example. What is the capital of France? Okay. Hit enter. The capital of France is Paris. We know how it is generating the output, right? Token by token. And do you know what? Let's do a quick revision. This question mark is used to generate the very next token, right? Remember, we just use the embeddings of the very last token, right? Then it is generating the, and then it is appending here like the, and then da will be used to predict the capital using LM head. Remember, it was fun, right? Now you know the technical terms. Now you know the technicalities of LLM, and now that's why I'm like so happy. So now we got the output. Okay, very good. So this is our prompt. This is our prompt. Simple. Do not make the things complex, right? Because life is already complex. So this is prompt. Prompt. This is my prompt. Now, yes, we have so many different types of prompts, but first of all, try to understand what is prompt. Okay, because prompt is a very fancy term and very new term in terms of, you can say, among developers. So yeah, that is the term we use for prompts. Make sense? Now you will ask a very simple question. Ansh Lamba, we understood what is a prompt. We understood. But why it is important? That's a very good question that anyone can ask you. And this is a question that you can ask from yourself as well. Like, why prompt engineers are in demand? Because first point, control. What kind of control? Control over the output. Prompts determine the quality, relevance, style of model outputs. Okay, a well-crafted prompt can elicit more accurate, creative, and useful response. That's why you would hear this thing a lot in the industry, that you need to know how to use LLM, how to work with LLM. Because let's say there are two developers, okay, there are two basically people, and both have the same goal. Both want to just get the output from the LLM. Person 1, or basically person A, is able to get the better response. Person B is frustrated and he or she is not able to work with LLM. Do you know the reason? Because person B is not aware of how to write better prompts. That is why the person is frustrated. But person A is very happy. Do you know why? Because he or she has watched my video. So he or she knows how to just work with prompts. So when you know how to work with prompts, you can generate better outputs. Just a keynote, I know it is not possible every time to write better prompts, because sometimes you are in a hurry and you just need to get the answer. It is fine. I understand that. But when you know that you have some time and your output that you are going to use from the LLM gonna impact a lot, then you need to make sure that you are using the right prompt technique as per the task. Make sense? This is the first point. Second is interpretation. What kind of interpretation? LLM interpret prompts based on their training data. Ambiguous or poorly worded prompts may result in a vague or incorrect answers. So as we know that our LLMs, large language models, I know, are trained on trillions of data. But that data is obviously, I know, is mix of technical data, well-structured data, some messy data, human written data. But on an average, the data makes sense. Sentences make sense, whatever you are passing. So you cannot write something like totally out of this world, that you are not able to understand what is written. So you need to write a prompt which is easily understood by any human or by a machine. Make sense? Very good. Then customization. Prompts allow users to customize the model's behavior for specific tasks, domain, or audiences. For example, let's say you are a stand-up comedian, okay, and you want to talk about a topic. Let's say you want to talk about bikes. So you will customize your prompt in such a way that you will get the output for bikes, you will get the paragraphs for bikes, so that audience will laugh. On the other hand, let's say you are going to work on some projects related to bikes, and that would require some research work, maybe some detailing. Then in your prompt you will make customization accordingly, so that you will get the output which will be helpful for your task. That is why customization is very important. Topic is same, both want to just want to get the output for bikes, but person A wants to get the output for, so that he or she can just crack jokes, okay. Person B wants some research work. So both need to do the customization accordingly. The last and not the least, efficiency. This is very important. Effective prompts reduce the need for post processing and corrections, saving time and effort. For example, you are in hurry, I know, and you just passed a very bad prompt. What will happen? Model will give you the output, obviously based on the decoder structure architecture. You will get the output, but you will realize like, hey, this is not generating the desired output. Why? It's not model's fault, it's your fault, because you didn't pass the desired input, desired prompt. So it is directly related to efficiency. If you do not pass a very good prompt, you would be just spending time to let's say making it more curated and making it more enriched, and it is not a good practice. Okay, again, we all are humans and it is a new thing for us. I will not expect from you to every time write the perfect prompt, but When you will know about these prompts, you can accordingly switch between the prompt techniques, because there are so many techniques, right? Very good. And you need to be aware about those strategies. Makes sense. So now what I'm gonna do, I will first of all tell you the very first, and this is the prompt technique that everyone uses. Literally everyone uses. Okay, what is that particular prompt technique? It's called zero shot prompting. Very fancy name, right? Very fancy name. Zero shot prompting. What is zero shot prompting? See, everyone. Let's say you have given a task to model without any examples. Oh, without any examples. Okay. So what will happen? It will purely rely on its pre-trained knowledge to generate the response. Make sense? I haven't said anything special. Zero shot. Zero shot means you are solely relying on model to perform. You are not helping model. Nothing. Zero help is given to the model. So what will happen? It will simply do whatever the model knows and whatever the data it has used while training. Make sense? Make sense, make sense, make sense. Advantage, obviously time saving. You do not need to spend time to curate your prompt. And do you know what? It is very useful. Very useful for generic tasks. What kind of tasks? Let's say I want to translate something to something. I can do that. Let's say I want to find a meaning of a word. I can do that. I do not need to pass the example. So this is zero shot prompting. When you need to get some work done quickly and that task is not very, very complex. That model needs some help. And you know that model is eligible enough to do that task even without any help from your side. Make sense? Make sense? Make sense? Do you want to see any example? Let's see. So let's say, let me first of all refresh it. So I will say, bro, what is, give me some complex word. Give me a complex word. Let's say, hey bro, what is VS Code? Let's say there's a person who doesn't know about VS Code. Okay, it's a code editor by Microsoft. But let's say the person doesn't know. So now here, the person doesn't need to follow a very structured way of passing the prompt. The person can literally use the generic language, generic, you can say, tone that the person is using in day-to-day activities. Literally, because model is eligible enough to give you the output. Okay, the output that you will be using and it will be helpful to you. Let's hit enter and it will say Visual Studio, VS Code. Visual Studio Code is a free lightweight code editor made by Microsoft. It's super popular because it's cross-platform, blah, 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 blah. Your work is done because your intent was very clear that you want to know about VS Code and nothing else. And nothing else. You do not want anything special, right? You do not want anything special. Make sense? What I'm doing? You do not want anything special. You just want to know something. You are not going to use this output. You are not going to just, let's say, write a blog, nothing. Just want to know something and your work is done. So this is very handy. Zero shot prompting. But there are some limitations. What are those limitations? First limitation, if you want to get some complex work done from LLM, it will not be able to do efficiently. Why? Because no context or guidance is provided to the model. Nothing. You just said, hey, just do this. Hey, just do this. Make sense? Make sense? Make sense? Make sense? So now, here comes the second strategy which takes care of that thing, and it is called few shot prompting. I think you are eligible enough to understand it without a second thought. Few shot prompting. In short, when we talk about few shot prompting, we are just trying to help LLM. We are trying to help the model to generate the output. Few shot prompting means when you pass some examples as well in your prompt. In your prompt. Okay. Let's say you want to get some work done. Okay. You said, hey, can you do this? Okay. Along with that, you will pass some examples as well. Few shots. Few shots mean like few examples. Zero shot means zero examples. Okay. So zero shot means we are not helping the model, but with few shot we are helping the model. Make sense? Make sense? So this way model can recognize the pattern and it can produce more accurate outputs. Make sense? So you will say, Ansh Lamba, what kind of examples we need to pass? Basically input and output pairs. What did I say? Input and output pairs. Make sense? So let's say you just want to translate something. Okay, you just want to translate something. So let me just bring the screen. So let me just refresh. So let's say you want to translate something. You will simply say translate I want to eat chocolate, okay, to French. Make sense? So this will just simply try to do it in French. It will just simply translate it. And obviously nowadays LLMs are very, very powerful. We do not actually need to pass some examples to these small tasks, but this is just a hypothetical situation. Let's say you are asking LLM to do a complex task. Okay. So here you can simply pass what examples. You can simply say input. Okay. Input is let's say want to eat chocolate. Let's say I love my country. Input, and then output. Obviously I need to first of all translate it. Okay, so I love my country, and let's see in French. Do you know why I'm laughing? I will tell you. Wait, let me just first explain this. Okay, so this is the text. So let me just copy it and I can paste it. So now I have passed one example as well. Okay, let's hit enter. Oh man, but you can see the output in the background, right? Stay locked out. Okay, best. Okay, so now what I got? Input and output. Do you know what? If you closely observe what actually happened, yes, it translated my sentence I love my country to desired language, let's say French. But this time model obviously used its knowledge, but it was influenced by my input, by my example. So it generated the input in the same way that I have provided the example. So this helps the model to customize the output. So that is why whenever you just want the output in a certain format, it is always recommended to use few short prompting where you can literally pass some examples like how you want your output. And you want to see the test. Let me just show you. If I do not pass this thing, let's say if I do not pass this example, if I simply refresh the screen and if I simply say, hey, translate this to this. So what it did, translation of this is this. So it generated the text, it generated the output on its own. But previously when I just passed few shots, I got the desired output according to my requirements. So this is few shot prompting, and let's talk about why I'm laughing. So here in Canada, so we have some government offices. So let's say if we just want to get some work done, we have to just go there. Okay. So whenever you go there, because in Canada, they speak English and French both. Okay. So in some provinces, they just speak French. But in most of the provinces, they speak English and French both. But some people just speak French because it is their first language for some people, right? So what happened more recently, so I went to that office because I wanted to get some work done. Okay, and I was with my friend. So and they greet it like this. So whenever you just go to the counter, and there are like multiple counters, so whenever you just go to the counter, they will greet you. Like if you just go to your country's any service center, anywhere, so you'll simply say hi, hello, whatever in their language. So here they say same thing. Every person will say this line, hello, bonjour. Hello, bonjour. Hello means like greeting in English. Bonjour means hello in French. So they say these two words, hello bonjour, hello bonjour, that's it. And I don't know what was in my mind at that time. And she said hello bonjour, and I was like bonjour, and my friend was like what, and he was literally thinking how did he know French, and he assumed like okay maybe he knew some French, so he was like okay. And the lady started speaking in French, and she was just saying like I think she was saying like what do you need, like how can I help you, and blah blah blah. Like she said like for 1 to 2 minutes, and I was literally hearing everything. I was like okay, okay, okay. And when she stopped, I was like I just know bonjour in French, so can you please repeat the same stuff in English? And she gave me that weird look, and my friend just left the office because he was like laughing badly and he couldn't stop, so he just left the office, and I was just standing there because obviously I wanted to get my work done. And yeah, some days Ansh Lamba is out of control, so yeah, try it if you just want to try and just see what happens. But and next time what happened when I just went to the same office, because there's like 1 to 2 offices here for any government task. So when I went there, so I was just trying to go to the same counter because that counter is like usually empty because of less number of people go to that counter because it is at the end or it is at the corner. So when I was just trying to approach to that counter, so she literally put that tag of like going to lunch break, and she just left. I was like okay, no worries, I can just go to different counter. So, moral of the story, if you do not know any language, do not try to be cool, okay? Just stick to your language, whatever you know, okay? Makes sense. By the way, yeah, these kinds of thing only I think Ansh Lamba can do. Like, you should not do that. So now, let's talk about other technique. You will say, Ansh Lamba, why do we need another technique? I think this is the perfect one. Not really. Not really. This is not the perfect one. And I would say not even a single prompting strategy is perfect. It just depends upon the requirements. And you know what? There is a one requirement where this prompting technology will not work very efficiently. It is called chain of thought. Let me just bring it that. It is called chain of thought, COT prompting. What is chain of thought? What is chain of thought? Whenever we want our model to think step by step before answering. Step by step. Why model needs to think step by step? Okay, let me ask you a simple question. When you think step by step, we do not think, bro. Forget about step by step. Be serious. Be serious. So you will think step by step if I will give you a mathematical problem, right? Okay, if I ask you this, hey, what is 5 into, oh wow, 5 into 3 plus 10 and then into 10, 120 and divided by 10. And by the way, forget about step by step. Just try to solve this. I want to see like who can solve this. Okay, forget about step by step, bro. You will be stuck at step 2 or step 3. So basically, whenever you will be thinking step by step, model will also think step by step, because model is just mimicking your brain. Do you know this? All the neural networks, deep learning, whatever they have just built, they have just tried to mimic your brain. So if you just want some work get done, you have to just ask model, bro, take a deep breath and just think step by step. Just think step by step. Okay. So here, just tell me, will that few short prompts work? Obviously not, because every equation will be different, right? So it doesn't just need to translate anything, it needs to perform some calculations. So what it will do, it will simply, first, by the way, if you do not know about this, it will not directly do 5 into 315, okay? I was so sure, you will not be able to solve this. I was so sure. That's why I just asked you, just give me the answer. I was so sure. Why it will not do this? Bro, if you have studied mathematics in your class 4th, 5th, so there's a rule, okay? There's a rule that your class teacher used to shout. and it says board mass. Okay, so let's say board mass. So first of all, bracket, we do not have any kind of bracket. Then O, I think a kind of operator, then division. So first of all, it will divide this number. Okay, so it will become 12. Oh, so now the equation will be 5 into 3 plus 10 into 12. So this is step number 1, right? This is step number 1. Very good. Then multiplication. So it will perform multiplication 15 plus 10 and not 10 actually, plus 120. Yep, because this is a multiplication sign. Okay, so this is step 2. So now step 3 is addition. It will become 135. I want to see like whoever solved this problem. Okay, the answer is 135. Make sense? Good. So you didn't solve the whole equation in one go. You did it step by step, right? Step 1, step 2, step 3. Similarly, you also need to tell model, bro, you need to solve an equation, but you can just think step by step. Ansh, Lamba, we understood it very well, but just a quick question. Can we say that we use chain of thought prompting with just mathematical situations? No. No. Mathematical situations is just one of the most popular areas where chain of thought works better. Okay. Second area is when you just want to do some research, when you want your model to think before answer, when you want your model to basically take some time before generating anything randomly. So there is a like this is a very special prompt technique, very special, literally very special. So how it works, the prompt asks the model to think out loud. And how we can ask, you can literally write think step by step, or answer step by step, or generate something step by step. You can literally provide that thing in your input. This is one way of it. So what it will do, the model generates intermediate steps before the final answer. So it will not directly generate the token. It will generate the token, it will just examine it, and then it will generate the final token. Make sense? Make sense? Make sense? Make sense? So let's say, I will simply say, solve this. What was the equation? I think 5 into 3. Then what was the equation? 5 into 3 plus 10. Not 10, I think 120. I don't know, man. I think, yeah, plus 10 into 120 divided by 10, right? Because 15 and then 120. Yeah. So let's see. Solve this thing. See, I didn't ask it to do it step by step, but it did it automatically. Why? Because it is programmed. Whenever we get something like this, any mathematical situation, it needs to do it step by step. So first of all, it did 5 into 3, 15, and then 1200 or whatever by 10 and whatever rule. So we got the answer 135. Make sense? Second way of doing it is this. So let's say I want to just use chain of thought prompting to write an email. So write an email to my boss about my skills, like something like this. Obviously you will not write this email, but, and then I'll say think step by step. So now it will, obviously you will not see the step by step thinking process and all, because it is so fast, but now it will think it before generating the output. That is why you have got such a detailed output with the final, obviously this thing. So chain of thought is a very strong technique, okay, that you should introduce in your day-to-day activities if you are just using LLM. Make sense? Okay. So these are the four most, like 4 or 3? Yeah, I think 3. 3 major used ones. Okay. 3 major used ones. There is a fourth one, okay, which is I think very popular nowadays, because now people know how to work with LLMs and they want to customize their output. And what do I mean by that? So if let's say we want to do the customizations, we use instructions based prompting. Instructions based prompting. What do I mean by instructions based prompting? when we want our model to create the output based on our instructions. For example, there's a long passage. Okay, you will say, bro, summarize this in one line. Wow. So what it will do, it will not generate 100 lines just for the sake of summarizing. It will only generate one line because you have passed the instructions that you need to do it in one line, and that's it. That's it. Make sense? So let me show you an example. So let's pass a prompt, and I will say, do you know Ansh Lamba? Okay, let's see. So it generated this, and I don't know why it doesn't know, because just test your normal chat bot, any chat bot, they will know. I'm so sure. Okay, so this is like normal text. When I pass that prompt like this, do you know Ansh Lamba? Just answer yes or no. So what I did, I simply ask it to answer it in yes or no, and that's it. So do you know what? It will simply say no. It didn't even generate anything extra after no. This is called instructions based prompting. When you are customizing the output based on your output, basically instructions. Make sense? Make sense? Make sense? Very good. Again, very strong. See, every prompt strategy is important, is very critical. It all depends upon the situation. It all depends upon the situation. And these are like very small examples. Just think about when companies are trying to build so many like huge products, and they want to just keep their prompts curated because they know that it will affect their token size, it will affect their pricing, it will affect their cost, everything. So that's why prompt engineering is in demand right now. But earlier, people used to think, hey, prompt engineering is just like asking LLM to do something. No, bro, it is not like that. And you will get to know a lot about that as well when we will be just covering the topic for RAG. Okay? So don't worry about that as well. So this was all about major 4 types of prompts that we have in the AI world, in the LLM world. There is 5th type of prompt technique, which is used with the agentic AI specifically, not with normal LLM or not with normal AI. It is only used with agentic AI. What is that technique? That technique is called React prompting. And this is a very powerful prompting technique. Again, it is only used with agentic AI. By the way, what do we mean by React? And by the way, Anshulamba, you have put A capital. This is not a mistake. I have purposely put A capital because this is not like a React. This React word is made up of 2 different words. It's called, what is this? It is called reasoning and acting. 2 words, reasoning and acting. React prompting. What does it mean, reasoning and acting? See, whatever things we have done so far with prompts, we simply acted. That's it. Like not we, like LLM just acted. It actually didn't do the reasoning part. It didn't do actually the observance part. Can you explain it a little bit in detail? Yes, sure. So let's take this example. Okay. So let's say this is you. Okay. Tech geek. And let's say your name is, what name should we, if I take normal names, then you will say, hey bro, why are you taking my name? If I will take XYZ, you will say, bro, take real names. Let's take this name, Pappu. Okay, don't laugh. Why are you laughing? Pappu is also name. Don't be judgmental. Seriously, bro, seriously, look at you. Come on, man, come on. So let's say this is Pappu. Let's take the name as um wow. Let's say Aman, because this was the most common name when I used to study in my grade 1 or 2 or 3. In every chapter of English, Aman, 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 Aman. I was like, wow. Let's take the name Aman. Okay. So let's say this is Aman, and this boy is trying to use LLM. Okay. Now this is LLM, and this LLM is not just a normal LLM. This is an agentic LLM. Now what is the difference between normal LLM and agentic LLM? So basically, obviously we are not going in deeper in agentic. We will just cover agentic topics as well in the future videos. Do let me know if you want agentic videos as well. We will just cover that as well. But for now, we are just simply trying to understand the fundamentals, bro. I know you want to learn everything, but step by step. Very good. So agentic LLM. Agentic LLM has some more features, some more powers. Powers such as tools. Tools are one of the biggest powers that agentic LLM has. Tools. What kind of tools? So if you are not aware, LLM just predicts the next word, right? Yes. So if I asked LLM to perform the multiplication, remember our mathematical equation? Remember? So how did it perform that particular calculation? How? It cannot perform mathematical equation. So it has some tools. Let's say it has a tool called calculator. So that calculator actually did the calculation. This is one tool. Okay. And it has, let's say, another tool called Google search, where it can just search anything on Google to just get the latest news, because obviously LLM will not be having some news. Okay, let's say Google News. Make sense? Let's say it has one more tool called research. It's called Arxiv. Okay, so let's say research. Let's keep it simple. So let's say research. So it has these tools available. Just for the quick understanding, you can treat these tools as different APIs that it can just access. Okay, so these are its tools. So do you know what will happen now? So now this particular prompt will go to this LLM. So let's say that mathematical equation. Okay. So what it will do, it will simply say, or anything, let's say anything, prompt, literally anything. This prompt will go to the agentic LLM. Agentic LLM will obviously read the request. Okay. So this person needs this. Okay. So now if this LLM thinks that, bro, I cannot fulfill its demand, I may need to use a tool. So what it will do, it will simply make a tool call, let's say to the calculator. Okay. So this calculator will give the results back to the LLM. Okay. What did I say? This LLM will make a tool call to the calculator, and this calculator will generate the response. This is called acting. Okay. Action is done. Now LLM will again do the reasoning part. It will access this output. So let's say this output is generated like this. So this is the output. So this output will again go back to the LLM and it will reason it. It will observe it. So okay, calculator has given me this result. Should I just generate the final output? Do I have all the things? So if answer is yes, it will give this output back to this user. If not, it will make another tool call and it will keep on doing this thing. This loop, it is called react loop. Reasoning plus acting, reasoning plus acting, reasoning plus acting, until this LLM is ready and satisfied to generate the output to this user. Because let's say you have written a prompt like this. Solve this equation and give me today's weather. Okay, both the requests are different, but you simply passed one prompt. It's you. Okay, so now obviously it first made the tool call to calculator. It got the result. Tool call agentic LLM just observed the output. So it said, bro, something is still missing. I still do not have today's weather. So then it will make the tool call to, let's say, any different tool, let's say any API, weather API, and it will get that as well. Then it will do the observation part. Okay, so I have calculation. Okay, I have weather. Okay, is there anything else left? Not really. So let's generate the final output. So this way it will generate the output that you see on your screen. But under the hood, it just perform this thing, agentic thing, a react thing. And currently, all the LLMs are agentic LLMs because they have some tool calls available. But I would say it is added more recently, but before, agentic LLMs were not capable to do anything. That's why whenever you used to pass any mathematical question to LLM, it was giving some very you can say garbage result. Why? Because it didn't have any kind of tool call available. Make sense? That was the reason. But now they have tool calls available, because obviously industry is moving very fast. Also, you need to also move it. So just tell me in the comment section. I will just make that video on agentic AI as well. But first you need to understand the AI. You cannot understand directly the agentic part. So feel happy that you are just understanding all the fundamentals. Make sense? So this is all about the prompts, all the prompts. Do we need to know anything else? Not really. First, practice these things. Try to implement these things in your day-to-day activities. You will see a major difference in your outputs and you will love it. Make sense? So this is all about the prompting techniques. Now we need to discuss something in very much detail, and it's all about RAG. It's all about vector stores. What are those things? We're going to talk about that in detail. So don't worry about that. Let's see. Finally, it's time to talk about RAG and vector store. And you know what? It is one of my favorite topics because it is related to data. Like obviously everything is related to data, but it is related to data storage. And whenever it comes to data storage, data engineers smile like this. Why? Because see, we own the data stores, right? We own the data warehouses. We own where curated data is stored. So obviously vector store is among those curated storage layers. So we own that thing. Okay. And you know what? You will understand everything. Don't worry. You will understand my point that why this thing, I always keep on saying, okay, and I will be keep on saying that AI engineering is actually incomplete without data engineering. So if anyone, let's say there's an AI engineer, okay, there's a data engineer. Both are not future proof. Both are not AI proof. Okay. The complete domain is called AI data engineering. That means you need to learn AI concepts after data engineering. And if you're an AI engineer, you need to learn data engineering concepts, because both go hand in hand. For example, software engineering. Earlier there was a race. Is front end better or back end better? People keep on fighting. The smarter ones actually learned both and became full stack developer, and actually full stack developers started growing rapidly. Same thing here as well. Currently people are fighting AI engineering versus data engineering. Bro, learn both. Okay, learn both. Obviously software engineers have already turned into AI engineers. You know very well, people are building applications, blah blah blah. Data engineers are currently focusing on dimensional data modeling, data warehouses, everything. They need to learn AI engineering as well. That is why we have this video for data engineers. So now what will happen? Data engineers will get the priority. Why? Because companies will not hire AI engineers only. They know how to work with APIs. Okay. And in very near future, those API building will be very easy. So not a big deal. Orchestration is not a big deal. LangChain, LangGraph, Microsoft Agent Framework, Databricks, Bricks agents, everything is trying their best to do all the things easily deployable and easily, anyone can build those things easily. The thing is, companies will be looking for those people who can build data warehouses, because that is the backbone of anything, including AI, including everything. On the top of it, once you have created your gold layer, your dimensional data model, your data warehouse in Azure, in AWS, anywhere, okay, then they need someone who can then build the AI solutions as well on top of that data. So the complete domain is AI data engineering. Okay. It's your choice. It's your choice. If you just want to trust this guy, you can. Otherwise, it's your life, your decisions, whatever I can say. Okay. But yeah, my responsibility is just to give you the real picture. Okay. Okay. Makes sense. So that is why this channel is dedicatedly built for AI data engineering domain. This YouTube channel is dedicated to AI data engineering community. Data engineering plus AI as well, both. And trust me, after this channel, you do not need to go anywhere else. I'm so sure. So just relax and just trust. That's it. Okay. Very good. Very good. Each and every topic will be covered, bro. Each and every topic. Just wait for the videos. And there are so many videos already created. Okay. Just enjoy. Okay. So now we want to master RAG and vector store the same way we have mastered all the previous concepts. Done. Let's do it. So, do you know what? When I was learning about RAG and vector store, first of all, both are not different things. You can say both are interrelated. Some people preferred it calling RAG because RAG is a complete process and vector store is the backbone of RAG. Okay, basically vector store is one of the most important step within this process. So these words can be used interchangeably. Okay, so when I was learning about RAG and vector stores, I was like what's going on? Because if you want to understand RAG, you have to learn and understand it in the reverse order. What do I mean? So basically, if you will first try to understand what is RAG, what is vector store, you will not understand. But if you will understand why RAG and why vector store, you will understand RAG. Really, just try this. Okay, you can just try reading some blogs and videos. Okay, just try to see like what is RAG and let's see like if you are able to understand. Okay, now let's continue with this part, like this section of my video, and let's see if you are able to understand it or not, because I'm so sure this is not the first time you are hearing this word. I'm so sure, bro, these words are so popular. I am so sure that you would have read about these things or maybe saw some videos, anything, but you didn't actually understand it. Now let's see what's RAG and vector store. Let's see. So basically, RAG and vector store, we first need to talk about why RAG. Okay, why RAG? Basically, let's try to see what we are doing so far, what we have done so far. So let's say this is you. Okay, and you can just imagine your own name. I'm not giving any name. Okay, I will check what are the most least used names. Okay, so let's say this is you and this is our LLM. Okay, chat GPT, whatever. Okay, and you can just try it with your chat GPT as well right now as well. Okay, LLM. So you go to this chat GPT and you say what is the capital of Paris? Okay, it will give you the output. It will simply say France. How it is able to do this thing? Because LLM knows it is France. How? Because LLM is trained on some data, right? Let's say this is its data on which it is trained. Let's say this is its data. Okay, so this information is available in this data, LLM's data, because obviously this is trained on a data. Very good. Now you asked another question and you said what is my father's name? It will say, I don't know. Who are you? Who is your father? Or this is like a very personal question. Let's say you ask this question, what is the weather? Because I don't want to use this example, what is the weather today, because nowadays LLMs have those tools. So let's use a different example. That was a good example, by the way. Now let's take an industry example. Let's say you are working in a company called XYZ. So you said how much sales we made last month. LLM will say, what's wrong with you? I don't know, because I don't have that information. So now you will not get any response from LLM, right? Why? Because LLM is not aware of your organization's sales, your organization's balance sheet. Now what if I say, I want LLM to be aware of this information as well? Ansh Lamba. So are you trying to say we need to send our data to Sam Altman? Not really, obviously. But what you can do, you can use this concept called RAG. What is RAG? We are not talking about that thing, but just assume that this is a process in which we can pass our information. So what will happen? I will attach my own data as well with this own pre-trained data. So let's say this is its own internal data on which it is trained. I have attached one more data here, and this is my data. Okay. This is my data. Okay, perfect. So now if you ask this question, how much sales we made last month? Now it knows. It will say, let's say 100K. Okay. Why it knows? Because now it has the data of your organization. So this is called RAG. Now you understood? See, that's how it works. That's how it works, bro. See, so now, in short, RAG is nothing but just a process when you provide some context, some internal data of your organization, of your own personal details, anything to LLM so that it can access that data without exposing it publicly. Okay, because you're not sending any data to LLM that, hey, train yourself on this data. No. RAG is not like that. No. You are not asking LLM, hey, just train yourself on this data. No, we are not training any data. We are not training any LLM on this data. We're simply adding it as a context. How? You will get to know about that, but this is just a process. For now, you can understand it like this. Okay. Make sense? Very good. Now let's see RAG in detail. Like, what is RAG? First of all, RAG stands for Retrieval Augmented Generation. Retrieval Augmented Generation. Now, what is retrieval? This is the first step of it. What is retrieval? So you remember that we attached, this is LLM, okay? And this was LLM's internal data, like this, okay? And this is our data, right? This is my data. So retrieval, that means this LLM will retrieve information from this particular data, okay, from this particular source. Okay, basically this is a process of fetching relevant information. That's it, nothing else, just relevant information. From where? From my data. From my data. Okay, it can be a database, it can be anything. For understanding point of view, you can say it is a folder where we have saved all the information. So it can go to that folder and fetch the relevant information. Very good. Augmented. Augmented means it will use that information. It will use that information and it will enrich the input. So what will happen? So let's say I ask this question, how much sales we made last month? This was the initial input, right? This was the initial input. Make sense? Make sense. Now this initial input will be enriched. How? Because this retrieved information will be attached here on the runtime. Oh, so now this question will be appended with this information with my data. Let's say there are some balance sheets, there are some aggregations, whatever, some information, some context is here. Okay, so now this augmented thing means enhancing or supplementing the LLM's capability to generate relevant or basically more accurate output. And third step is, as you know, generation. Basically, it will use the augmented prompt and generate the better output. Make sense? Make sense? Makes sense. Very good. This is RAG. This is RAG. This is a process. This is an end-to-end process. How does it do all the things and what are vector stores? We want to know that as well. But just tell me one thing. Did you understand RAG? If we just want to summarize what is RAG. So you know what is RAG, right? We'll talk about how does it work, because I haven't touched this topic so far. How does it work? But you know what it actually delivers. And why do we use RAG? And why RAGs are so popular? Because LLMs cannot be trained on our data every time. It is trained, I think, once a year. So you cannot rely on its pre-trained data. Currently, we are building RAG applications on top of our let's say everyone is building RAG applications on top of their data, on their company's data. So they cannot rely on just RAGs or basically they cannot rely on LLM's pre-trained data. They have to use RAG, right? So that they can pass some context. Make sense? Very good. So now we need to understand how does it work. Okay. And actually the backbone is vector store. Remember, I said that we can store this information in a folder. Remember? And I said we can just store this information in a database as well. But in reality, there's a specific term for it. It's called vector store or vector database. Vector store or vector database. Two names, same meaning, same concept, nothing else. Do not need to worry about anything. People will say, hey, these are different. Both are same. Vector store, vector database, simple. So whenever we want to store our data, now what can be the data? Literally anything. Text file, PDF, CSVs, anything. We do not store it anywhere. We store it in that vector store. Now it will be a little bit more technical. Okay, so just be ready. So we save this data to this vector database, to this vector store. But why? Why just vector store? Why there is a specific vector store that we use? Why? You will know the reason why. To understand this concept, again, it should be learned in the reverse order. We first need to ask this question, why vector store? Okay, then you will understand it. See, this is like tested on myself. Okay, when I was learning, I was like, what's going on? Okay, so I have to just practice the best way to explain the stuff so that you can just understand it. So basically, why vector stores? Why? You will know the reason why. So basically, let's say you have a PDF file of I would say 1,000 pages. Okay, and it's very normal if you're just working in an organization and let's say your all the sales, everything is actually aggregated in the PDF format, and it's a kind of year on year sales revenue report. It's a kind of annual report. Okay, so let's say annual report. Okay, annual report, and this is a PDF. Makes sense. It looks cool, man. Okay, this is our PDF. Makes sense? Very good. Now this is you. Let me draw you. Okay. Okay, so let's say this is you. So now you are, oh, my thumb. So it is hurt, but it's fine. So let's say this is you and you are trying to query this. You are trying to query this LLM. Okay. This is LLM. And this LLM has its own information, which is the data. Okay. And now you will say, obviously I will pass this PDF. Okay. Here. Currently no vector store is in the picture, but we are simply trying to answer like, why do we need vector stores? Okay. So now, you know, in order to get the relevant output, because your question is related to this report, you need to put this report here, right? So you will simply say, Ansh, Lamba, why don't you attach the entire PDF here directly? Why? Why don't you do that? Forget about vector stores. People are mad. Let them talk. Just you just attach this PDF directly here, the full PDF. Okay. And what is the size of this PDF? 1000 pages. Very well done, bro. 1000 pages. Very good. Okay, let me do that. Okay. Makes sense. I did that. Um will it give me the desired output? The answer is yes. The answer is yes. I will get the output. Yes. But the answer will not be or may not be very accurate. Okay. Why? Because the context window is very, very big. LLM is literally trying to figure out what part, or just forget about that. Wait, we will discuss about that. Yes, you will get the result, accurate result. Let's assume you got the accurate, the most exact number you got. Let's assume this. And it can be the case. You can just get the accurate results. It's not like that. But why don't we do that in real world? Let's say now this PDF actually grew. Why? Because this 1000 pages PDF is just annual report. Let's say now your organization has been running for 10 years and now you have 10 PDFs. So now this one PDF will become 10,000 pages, will be of 10,000 pages. Okay. So this will keep on growing, right? Okay. So now you will be say you can just attach it here, right? This is your intuition. Okay. Let's do that. What is the issue? What is the issue? First issue is context window. Okay. What does it mean? It means you cannot pass so many tokens in your input in one go. Context window, right? It's not allowed. Second thing, cost. Ansh Lamba, what cost? This is my PDF. It is available for free. Bro, whatever you are just passing as an input, whatever you are passing as a prompt, it is directly aligned to the cost, right? If you are not aware of this, you should be aware of this. Everything is aligned with the cost. Every token is aligned with the cost. So just imagine, okay, let me just give you the scenario. Let's say this is of 10,000 pages, 10,000 pages. Okay. And you asked this question. You asked, how much sales we made last month. Okay. Or let's say we made in the first month, or let's say we made in total. Okay. In total. Simple. How much sales we made in total? This is your question. And obviously this is a common sense. In all the annual reports, you will see this question, okay, answered in the very first or second page. It's common sense because it is an annual report. So obviously it will be highlighted that, hey, we made this much of sales in total. And then further pages will be just breaking down that thing by cost and blah, 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 blah. So what is the intent here? Our answer is actually available on the second page. And you passed how many pages? 10,000 pages. Why? Because you are so rich. You are so rich. You do not need to worry about token size. You are like richy rich. But your organization needs to save money. Okay. They cannot just spend whatever amount you will ask to spend. So now they will simply say, bro, if the answer is available on the second page, why are we just passing 10,000 pages? We just need to pass that particular page, right? Oh, so Ansh Lamba, who gonna read the PDF and who gonna tell me that on which page I have the answer? Okay, well, the answer is vector stores. Oh, really? Yes. Now let me just tell you what happens. So remember, this is our annual report of 1000 pages. Okay, or let's say 10,000 pages. Okay, so what will happen here? 10,000 pages. Now we will create something called as vector store. Okay, or let me just draw nicely because I was a great painter of my class. Really, yes. I love like oil pastels color. If we have used by Camel, I was like, wow, man. So this is a vector store. Okay, vector store. So what I will do, I will create chunks. Oh, I will divide this 10,000 pages. Okay, this PDF basically, whatever size, I don't care. I will create each chunk, or let's say each chunk for each page, just for the simplicity. So what I will do, I will create chunks. Each chunk contains one page. Okay, so what will happen? 1, 2, or even before that, let's say 1, 2, 3, 4, 5, 6 till 10,000. Okay, till 10,000. 10,000 chunks. Now what will happen? You know what will happen. Now these 10,000 chunks actually contain the text. Obviously in PDF we have text, numbers, whatever, like normal text. Okay. In order to convert them into numbers, what we do? Embeddings. So what we gonna do? All these 10,000 chunks. Okay. All these 10,000 chunks will go to this vector store, in the form of embeddings. Oh, so there'll be 10,000 embeddings here. Okay, makes sense. So whenever we say we need to store our data in the vector store, we are trying to say that we will take our data, we will create chunks, small chunks. Why chunks important? Because we just need relevant chunks. We do not need 10,000 pages. We just need relevant chunks. So it will create embedding vector, or basically you know the embeddings now. So it will create embedding and it will store that particular vector here in this vector store. Okay, one thing to just note, it will create one vector per chunk. But Ansh, Lamba, we have studied that it creates embeddings token by token. So let's say in one chunk we have, let's say 100 tokens, or let's say so many tokens, let's say 100 tokens, because there can be 100 words in one page, right? You are absolutely right. So it should create 100 vectors, right? Why it is creating one vector? So obviously it is like common sense. It will first create 100 embeddings, like each embedding per token, because that is a fundamental step. And then it will aggregate those 100 embeddings and it will create one final embedding, which will have the whole context of the sentence, or basically whole context of the chunk, whole context of the page. So it will create only one vector embedding per chunk, per page. But initial step will remain the same that we have studied, one embedding per token, and then it will just sum up those things so that it can create only one vector here. Make sense? Don't worry, I will just show you all of these things. I have a written code in my own VS Code platform. So obviously that would require so many APIs to use. So you do not need to run those code. You can just observe, and you can just, it is just for your explanation. Okay. By the way, it is not required. This coding is not required because it is a part of Agentic AI deployment. It is not required, but I want to show you so that you can understand how it goes. Just for the understanding point of view, that's it. So you do not need to worry how to run this code and blah, blah. You do not need to run this code. I'm again repeating. I will simply show you for your better memory retention. Okay. I don't want to start the psychological class behind that, but it is good for your learning. Trust me. Makes sense. So 100 tokens, 100 embeddings, and one vector per chunk. Very good. So now we have 10,000 embedding vectors stored in the vector store. Now what will happen? Now same thing. You will ask the LLM about your question, maybe how much sales we made in total. So now do you know what will happen? This query, like your query, that whatever query you have, let's say you have this query. Okay, this is your query. Okay, and these are the vectors, right? Obviously this information is not available to LLM, so it needs to fetch it from vector store. And it will not fetch all the vectors, as we know, because we do not want to fetch 10,000 vectors. It doesn't make any sense. We just need to fetch 3 vectors. Top 3 vectors. What did I say? Top 3 vectors. I want top 3 vectors. Okay. And let me just draw this LLM a little bit further. So let's say this is your query. Okay. Okay. This is your query. This query needs to go to LLM. Okay. LLM is here. Okay. Makes sense. LLM is here. So before this query go to LLM, now we want to attach the data, basically add the data, because this data is not available here in LLM. So now I want to add top 3 embedding vectors, top 3 chunks to this query. So what will happen? It will simply drag top 3 embedding vectors like this. And what are these embedding vectors? Obviously the original text. Okay, so you can just imagine top 3 pages of this annual report will be here, will come here. Okay, so this query plus these 3 pages will go to LLM together. Query plus relevant pages, 3 relevant pages, not 10,000 pages. Okay, just 3 pages will go to LLM. And now obviously LLM can answer. Why? Because LLM will read the question and it will get the context as well. Perfect. This is the end-to-end process of RAG. And that's where vector store plays the backbone of that role. Understood the whole process? Understood? Good. Happy? Happy? That was it. Just one thing. And this should be your question. What's that? How these 3 pages came here and not the other 9997 vectors? Bro, 10,000 minus 3 is 9997. Okay. Why other 9997 vectors didn't come and only these 3 come? Why? First reason, we define how many chunks we want. We wanted just 3. Okay, sorted. Question is not complete yet. Obviously, how many vectors come? 3, because we defined. But why these 3? Why these 3? Why not these ones which are there? Why just these 3? Why? Here comes the concept of cosine similarity again that we talked in the beginning of the video. So what it will do? This is your query, right? Okay, this is your query. This query will be converted into a vector embedding. Query as well, yes. Why? You will see it, don't worry. So this will also be one vector. Okay, this will be one vector. It will be converted. Now this vector will be compared amongst all these vectors, all these 10,000 vectors will be compared using what? Using cosine similarity. So whatever vector will be the closest to this query, that means it is most relevant, and similarly it will find 2 more most relevant vectors based on the cosine similarity. And once it finds the top 3 ones, it will simply add it here like this, and it will go to LLM, and LLM will give you the answer back. Why? Because it knows the answer now. Perfect. That's how it works. That's how it works. Make sense? Understood the whole process? How vector stores, how RAG works. Understood? Very, very, very good. Very good. So now I want to show you the documentation of a very popular platform called LangChain, LangGraph, because these are the very popular frameworks, agentic frameworks we have. There are so many agentic frameworks, okay, for RAG, for vector store. And there are so many popular vector stores as well that I want to name. The very popular one is, I would say, Pinecone. And the other one is, I think I was using that one. What was the name of it? Because Pinecone is the hosted version. It is available on cloud. There's Fice. There's like one more. I used to use that a lot. What was the name of it? Pinecone, Fice, ChromaDB. Yeah. So these are very popular, you can say, vector stores available. Okay. So let's try to see RAG, let's say LangChain, because I just want to show you some images that you can just refer for your notes. Yeah, this one, this is very good. Let me just, because this image is actually created by LangChain. Obviously a lot of organizations, basically companies are using it, but it is actually created by LangChain. So I'm just looking for the official website. Or let me just search vector store LangChain. Search all vector stores. Okay, just put some images, bro. Everyone is using your images, maybe retrievers. What are you doing, man? What are you doing? Upload some good images, pictures. Medium.net. By the way, the illustration that I have given is like perfect, the live illustration, but I just wanted to show you something. Vector store and RAG documentation. Vector stores. LangChain. Bro, give me a good. Oh yeah, I found it. Perfect. So it's, first of all, that's exactly what we discussed. Okay. So this is the process for just vector store. Okay. So first of all, load. That means whatever PDF, whatever data you have, you split that data into chunks. Then you embed those chunks. Exactly what I said. Then you store those embeddings in the vector store. That's it. That is the end-to-end example that you need to know. That's it. That is it. Okay. And once this is stored, you can simply perform your RAG process that you know as well. Okay. Makes sense. So this is, I think, a kind of picture for that thing. So what will happen? This is your question. Okay. This will retrieve the relevant information from the chunks and it will add that thing, basically chunks, into your prompt, and then it will go to LLM and then it will answer that particular question. This is the same thing that we have explained in the live mode, so you can understand better. See, I could have just pasted this picture in my screen and I could have just explained you like this, but I wanted you to understand. Okay, that's my love and care for you. I don't know if you love me or not, I don't know, but I love you guys a lot. So yeah. Make sense? Okay, very good. So this is a kind of RAG documentation, and RAG is, I think, same for LangChain and LangGraph both, because like RAG is RAG, same for LangChain, LangGraph, any agentic framework, any framework is RAG is RAG. RAG is a concept. Okay, it's not just a tool, or it's not just a, you can say, a technology. It's a process. It's a concept that is just like almost same for everything. Make sense? So this is all about your RAG and vector store. So now I have demo notebook that I can just share it with you. Okay, I can just show it to you. You do not need to code it because there are so many dependencies, platform dependencies, virtual environments, libraries, API keys, paid ones, everything. So you do not need to actually write this code, but you can understand this code and you just need to understand it. You do not need to run it. Okay. So do not say, hey, I also want to run it. Those things will be covered in the future videos where I will just explaining like how to code and how to do all these things. Okay, so you do not need to worry about those things. So let's actually explore, and that's it. Okay, let's see. So let me now show you the vector database website and how does it look like and how you can just also work with, because there are so many different types of vector database, on-prem, in memory and cloud hosted as well. And I can just show you again, you don't need to worry about the code, how you need to write the code for this one, because if you want to, we will just cover these things in the upcoming videos. Just do let me know in the comment section if you want to. We will enjoy there as well a lot. Okay, because these are important for data engineering domain, very important, like RAG databases and all. Okay, so this is a kind of very popular, you can say, vector database called Pinecone. It is a hosted version of your vector database where you can just access your vector store anytime, because it is hosted. It is not on machine, it is not on prem, it is not in memory. You will retain the data. Okay, so you can simply go to sign up, and you can sign up for free. There are some tokens available for free. You can just play with it. Again, obviously you do not need to just do it right now because you are still learning the fundamentals. Okay, but why I'm showing you this, so that you will be feeling relevant. Okay, if I scroll down, you will see some demo code as well that you can just write to retrieve some tokens. And this was the intent behind showing you this. So here you can actually see top K thing, right? I told you that we usually just pull, let's say, top 3 embeddings, top 3 chunks. So this is a way we just pass these kinds of parameters, these kinds of arguments while retrieving the data. Make sense? Makes sense. And you can actually read the documentation for Pinecone as well, how we can just start, quick start, and everything should be there. Quick start section is very simple. You can simply see like how you can just do it, maybe from manual VS Code, Cursor, Claude, N8N, whatever you want to use, and you can just follow the steps. And it is pretty much simple. Okay, and it's up to you like how you want to just use it. Again, if you just want to, we will just create a dedicated video on Agentic AI RAG as well, so that you can understand all of these things, because being a data engineer, it is your area to master, and you have to master it in 2026 especially, because 2025 is almost over. And yeah, that's all for this video, I would say. And do you know what, I loved recording for this video, because I am literally feeling like you all are sitting next to me and we all are just having fun while studying. And literally I loved recording for this video. And you know what, I know that you also loved the video, but just show some love. Okay, on this video, you can just show your love in the comment section. It will help me to grow. And if you want me to grow, then obviously you have to take some actions, and just drop a lovely comment in the comment section. And do you know what, just click on the video coming on the screen right now, because this video is specially made for you if you want to just make your resume more powerful by learning this skill. Okay, so let me just see you there. Happy learning.